it, like in this case, carrying weights. As I said, we decided to design human robots, and we needed the money to do it. So what we applied for, I was just finishing my postdoc at that time, was European funding. In one of the first cases where Europe funded large enough projects, so we received about 8.5 million euros to actually run the project, design the robots. It was collaborative effort across Europe. These are the partners. We work with other people in Italy, but also in Switzerland, in Sweden, the UK, Portugal, and there were also companies involved that helped us with designing the mechanics, the electronics that was needed for, having something of good quality, good enough quality to be used in a research lab and break not too often. It breaks still. It's not an industrial robot, but was well done enough to be able to support our research. This is what we ended up designing. It's a robot of it's about 1 meter tall. It's shaped as a, 5-year-old child, roughly. The reason is that this was one of the few robots that we can keep in a standard laboratory. You don't need much support because it's not too dangerous. I mean, it's still heavy enough, but you don't want it to follow your feet. But normally you can work with a robot like this one. The other thing is that you can see from the picture to the right, it's a robot covered with tactile sensing, so tactile sensors. So there are about 4,000 sensing points across the robot body. I think there are not that many machines of that type, even to date. Touch is kind of underestimated. Sometimes robots have fingertips that are sensorized, maybe the hands are sensorized, but the entire body is very rare. And this is something we required another project and further development to actually design the sensors, but ended up providing some additional capability to the robot. Also, we like to call it, you see the Ferrari logo down there, has nothing to do with Ferrari, but we sort of consider this platform, this robot, as a Formula One car. Not because it's extremely fast in this case, but because it runs for the time of a Grand Prix, and then you have to replace the engine in the case of the car. And here, you probably had to replace tendons, you have to replace components. So there's a lot of maintenance work that is connected with using the platform. Couple of design things. We started with hands as in a sense, the most difficult component to design mechanically. We wanted a hand with articulated gestures, a hand that could do, for instance, pinch grip or power grasp. So 5 fingers, enough degrees of freedom. And this constrained, in a sense, the design of the entire robot. I mean, a hand with 9 motors, you cannot put the motors in the hand. So we had to move the motors into the forearm, which means you need tendon-driven fingers. And this constrains also further where you place the other motors. And the entire design is sort of constrained or conditioned by the fact we want to sophisticate hands. In terms of sensors, we were very strict at that time. So first of all, 3D cameras didn't exist in those days. So what we use was standard cameras, wanted to be able to do stereo vision. We had moving eyes, which I think is a feature that you don't see very often in human robots these days. They're typically fixed. Here we wanted to be able also to gesture by looking in certain directions, and we see later this is an important feature. We don't have everything else is tactile. I mentioned we have microphones, we have gyroscopes and accelerometers to sort of provide a sense of the body posture. We have 4-star sensors that give feedback on the contact of the robot with the ground, with the environment in general, besides the tactile sensing. And last but not least, we made open source. So even to date, the drawings and the software is available for download from our website. I mean, it's not perfect because, of course, we are a research institute. We can't provide complete support, but it was good enough to have other researchers kind of jump in with developing for the ICAB. And we eventually, I think, managed to create, at least for a certain number of years, a large enough community of developers that were working with us. This was an example video showing the hand of the robot. This is another, let's say, structure of sensors on the robot design, showing roughly where the sensors are mounted and giving an idea how relatively complicated it was to put so many connections, so many sensors on the robot body. And this is eventually, if it starts, it's a video that shows zero gravity control on the robot and the ability to basically keep the robot there, push the robot very gently, and the robot will keep moving just because it senses pressure, it senses the force that the person is applying to the robot. I think the video is old enough that it doesn't play on all computers. And I mentioned the fact that we had, or we still have, a community of users. So the ICAD, and end of last year, we had more than 50 robots across the world. I don't know how many of those are still used because, people tend to use the robot for a while because maybe there was, at least for the European robots, there was funding, there was support from European Commission projects. But, I know for sure that some of the robots are not used. But anyway, it all contributed in a sense to building experiments, building or designing or programming more behaviors on the robots and so forth. So it was a nice adventure. But let me tell you something newer. So this was history. What are we doing to date at the Italian Institute of Technology, more specifically? What you see here is one component of the research, and in particular is the component that studies social human-robot interaction, where most of the interest here is not on the robot, but it's on the human. Of course, you need a robot because the robot is being programmed to interact in certain ways with people. But here, what you can see is the typical setup in cognitive neuroscience, where we have a gaze tracker in the glasses, we have an EEG to record brain activity, there's a keyboard exemplifying the fact that we can measure reaction times, for instance, or other behavioral, let's say, we can collect behavioral measures that then can be used to clarify what's happening during the experiments and so forth. And the robot is fully interactive, also because these days it's very easy to have, for instance, a robot finding your face, looking at your eyes, being relatively autonomous in the interaction with a person. I'd like to start with a very basic experiment, which is mutated in a sense on something called Posner queuing. This is a very standard cognitive neuroscience experiment, and the original goes this way. You basically have a cue, which is an arrow that tells you, in a sense, where to look. And then you have a stimulus that can appear either congruent with the arrow or opposite, incongruent with the arrow. So let's say the trial on top is called a valid trial. This other one is called invalid. What we said, why don't we, in fact, replace the arrow with a human robot? I mean, it's easy to do. And also, in that case, we can manipulate the context because we can have the robot looking at you, or you can have the robot avoiding gaze. So the configuration of the experiment can be changed in various ways. This is a video showing how the experiment goes. You see, valid cue is when the robot looks in one direction and the letter appears in that direction. There's eye contact here. So the robot looks at you You can imagine the subject sitting in front of the robot. The other case, without eye contact, the robot looks at the table, in a sense, kind of avoids gaze, and otherwise the experiment goes as previously. Robot looks at one of the screens, and subsequently the stimulus appear. Okay, results. What we've done, like here is reaction times, for instance, is one of the measures that we can use. And what happens? Well, something interesting, because in the case of eye contact, like you can see here, there's a difference between the two conditions. The two conditions are the valid and invalid. So you're faster when the robot is cueing you to look in a certain direction. And in fact, the stimulus appears in that direction. So you're faster in saying, okay, I saw that. When there's no eye contact, in a sense, you're more distracted, maybe. There's no significant effect in the valid versus invalid condition. So this seems a nice story, and we thought, oh, maybe we found something. We tried manipulating a bit the timing of the moment the robot starts a movement and the moment the stimulus appears. This is called SOA. And in fact, what happens is the situation is completely changed. The two conditions have no difference. There's always a validity effect, both when the robot is looking at you and when the robot is not looking at you. Now, the question is, or the take-home lesson of this experiment is that this little change in timing actually modifies the perception, your perception of the robot as an interaction partner versus something that has a completely awkward timing, and therefore it's no longer an interaction time, a partner. And this is important, because if we're designing robots to be social one day, we may need to actually know when to start a movement. It's not random. It cannot be random, because otherwise we don't perceive the robot accurately as an interaction partner. Just as a summary of the experiment, well, there's an effect. So joint attention with a robot has an effect on the way we perceive the robot. And also that the robot gaze indeed is treated as a social signal. I mean, this wasn't necessarily to be the case. It was an empirical question. We asked the question, we ran the experiment, and we found that this is the case. I'm more, in a sense, I'm more interested in the question of the timing, because as an engineer, when designing a robot, I would like to understand when to do certain things. And the fact that I need to write a piece of software that decides when to do a certain movement is utterly important for how we perceive the robot. Another experiment along similar lines. In this case, there's a little video game that you play on a table. The table is a screen. In fact, there are two cars going one against the other. You can take a decision to deviate from the straight trajectory and therefore avoid crashing, or you can keep going and count on the robot maybe deviating. So of course, there's the robot has a strategy, there's a payoff matrix, so you get points when you don't crash. If you go straight, you get more points if you don't crash. In case of a crash, both you and the robot lose points. In case both deviate, which means you're not even trying, you get a small number of points. Now, the game is you have to try to win against the robot. And the robot can look at you again. So even in this case, there's a possibility that the robot is social in a sense. It looks at you, or antisocial, it's a bit shy and doesn't look at you. Here, the video shows exactly how the experiment is done. The robot actually presses the button to deviate. It does all of course, it's not strictly speaking needed, but this is makes completely realistic, and you play the game for a long time. Now, what happens? Well, there are interesting aspects also here. Also in this case is reaction time, response time. And you can see that, first of all, there's no difference from when the robot is on average more social versus the robot less social. So there's always an effect because the two colors are indeed different. But so it doesn't depend on the personality, so to speak, of the robot. So a robot that is more social doesn't change the effect. But when there's mutual gaze, indeed you're slower than the case when there's no mutual gaze. So a robot that is antisocial is better for you and you faster in responding. There's also a way to check that on the EEG. Particular, I mean, the way it works with EEG is that you do the measurements, then you go into looking across the literature to see whether differences, like in this case, during the task executions are correlated with activation in areas that have been related or already connected with certain effects. In this case, there's particular zone that you see in blue there, which is known to be related to the necessity to suppress a stimulus. In this case, we hypothesize is the robot that having to process the information that is coming from the robot. And there's also, I mean, this is identified with this higher synchronization during the mutual gaze in a certain frequency band of the EEG signal from a certain electrode that is placed roughly in the blue area that you see there. So there's confirmation in a sense that your brain has to spend some energy, some effort in processing this signal that is coming from the robot. Another test on the same experiment, this is even more interesting, I think, is the following. So if you have the robot that is not looking at you, so the averted one, this brownish bar here, look at the left most down plot. So the one that is exchanging gaze with you more often, the blue one, makes a smaller value of what? Of the time you spend on the optimal strategy. So you don't know the optimal strategy, but playing long enough, you start to learn something about the robot, and you start to use more and more the optimal strategy, which is called win, stay, lose, shift. So whenever you win, you keep playing the same action. Whenever you lose, you change action. So you press or not press the button. So what it means this is that if it's better to have a robot that doesn't look at you, maybe indeed the robot is a distractor. And therefore the take-home message is, if we designing robots for efficiency, maybe we don't want a social robot at all. I mean, it's much better to have a robot that doesn't distract you so you can focus on your task, which seems to be the case from this experiment. I think, again, this is another hint that for designers of industrial robots, maybe in the future, they can say, okay, if I go for efficiency and not for collaboration, maybe it's better not to have social signals. If I go for collaboration because the task requires collaboration, then I may need also the social signals. This is basically a summary of what we found with this experiment. So the robot can be distracting, in fact, and the delay and we're distracted, but also the delay is correlated to the necessity of suppressing an extra stimulus that is the robot looking at you. Let me move to a more of an application topic out of this research. So this is the same group that is working on programming the robot for interaction. We had the opportunity to work with kids diagnosed with ASD, and this is, we thought of using the robot because, at least in the literature, there were a few examples where there were hints that this may be helpful, and in particular to train kids that are diagnosed with ASD across battery of experiments and train them to behave correctly in certain conditions, in certain interaction scenarios. In particular, we ran a first experiment with a toy robot of that shape, a toy car, basically, remote controlled, can be programmed to behave in various ways and showing certain emotions, doing certain things. And we had positive results. It's not very important now that I go through the result here, just to give an idea that even with a simple robot, there are hints that certain things may be paying off, but it wasn't as good as later with the iCub. So eventually what we did was to prepare a full-blown experiment. We brought the robot to sort of a school, an institute where the kids get teaching, they have normal sessions with physiotherapists, but also they had the opportunity to play with the robot for a certain number of hours. And this is the how the experiment was set up. You see that we needed a glass or a plastic, a plexiglass wall from separating the kids from the robot. This is for safety reasons. I mean, the robot is not certified. We cannot have it interact with kids. Very, very dangerous in that case. And this is a video that shows some of the experiments, what the robot does. Basically, what we were training kids to do was perspective taking, and this first experiment. The cubes have different faces with different sides with different stickers. The stickers you can build a game where you're basically asking the kid to tell you what the robot is perceiving, what is the point of view of the robot. So in a sense, putting himself or herself in the robot's shoes and trying to get feedback from the interaction with the robot. So the robot can do yes, all good, or say no, it was wrong, and so forth. So this is the result. The test that you see here is the clinical battery of tests that is called NEPC2. It's normally used in clinics for assessing performance in certain tasks like geometric puzzles, but also theory of mind. And theory of mind is exactly perspective taking. And this is exactly what we wanted to measure and to see whether there's improve in performance over time after the kids played for several months with the iCub. Besides, they were all super excited to be playing with the human robot. Needless to say, this is also part of the therapy, probably. Okay, now results. Here we divided the kids into groups and have, so G1 and G2, both groups were going through the training but at different time. So we can actually measure whether after one run, there was improvement and we had a control automatically because the second group wasn't being trained, and we could check whether there was any change in the second group, which you can see here. So group one, the brown plot has improved in the theory of mind test because of the interaction with the robot, and the group two that did not interact with the robot, no change. And you can see also that after a time T2, we swapped the groups. So the group two at this point was interacting with the robot and being trained and going through the training. And in fact, there's an increase in performance. Importantly, group one didn't lose the capacity or didn't, the learning did stay. The other one on the right is interesting because it's a robot versus therapist, and it basically shows that the training works with the robot better than with a human therapist. And now the thing is, anecdotally, we can say that the robot is more fun. The robot is simpler. It's not like a person. It's easier to interact with. for a kid with ASD. And this may indeed be the case. And also the robot is more repeatable. I mean, it does the same stuff every single time. So it's a lot more predictable for the kids. So this is, again, summary. So nice to have a robot to interact with the kids. And this is turning into a larger program because we're still working with this institute, and there's an opportunity for all their kids to teach them to be autonomous. So there's, I mean, the numbers are frightening. There are a lot of kids that lack the basic ability to go around, to be autonomous, to carry out daily tasks. And there's a chance maybe through technology to actually teach them to reach a level of proficiency that will make them more autonomous. Let me move completely to a different topic now. I mean, we saw the social human-robot interaction. Let's move to the physical human-robot interaction. Physical, not to be understood as fighting the robots. This is more just exchanging forces and interacting with the robot. This is the first video just to show you some of the capacity of the robot. Of course, when we talk about physical interaction, we had to be able to do things like this one. So the robot is force controlled, and it measures interactions through tactile sensors and the force torque sensors that I mentioned earlier. And therefore, you can push it around, and the robot is reactive enough and can balance, like in this case. Now, details. The robot runs a multi-layer controller. The lowest level, it's a QP optimal controller that integrates all the data coming from the sensors and generating control according to a low-level task. There are two more layers. One that uses an approximate model for giving the robot the ability to balance and walk. And then there is yet another model, even simpler, that does the foot placement. So the robot decides where to put the feet at every cycle. And again, the three layers are integrated one after the other. So the foot placement is commanding the balancing controller, and the walking controller, which is commanding the QP controller that eventually commands each single motor of the robot controller. Now, in these experiments, we also decided to gather more information from humans, and I'll get to that in a moment, why this may be useful. And therefore, we designed a sensorized suit to measure roughly kinematics of the person. And additionally, we designed a pair of sensorized shoes to measure forces, exchange of forces with the ground. Therefore, we can use that measurement also to at least square calculate what may be the stresses on the various joints of the person. This is an example of how it works. And I mean, I think it does a decent job, both let's say the sensorized suit, but also the shoes. I'll show you in a moment a better representation that includes the shoes indeed. The shoes, by the way, they have force torque sensors, IMUs, temperature sensors, and they're completely wireless. So that's a added value that you can just wear them and you get the numbers. And this is a video where one of our students is playing with devices, lifting weights, and you see that there's a measurement of forces, but there's also measurements of the muscle articular stresses at the joints. This is useful in a context of the project that we received funding for, and this project was to actually try to estimate on one hand, what happens when you carry out certain tasks, what are the stresses? On the other hand, how the robot can help, in a sense, optimally to remove those stresses to your muscles. Motivation, 70% of injuries in work life are not because you do something completely dangerous, but just because you lift weights continuously. Sooner or later, over 25 years, those lifting weights causes articulatory problems. And people, at least in Italy, they file for insurance claims, and the insurance claims it's a lot of money, and therefore that's why they would like to have robots helping out in these cases. Now, with those sensors, there's more that can be done. And this is useful again if you're going to interact with a robot. You can train. This was a set of neural networks acting as a sort of a mixture of experts detecting or identifying different behaviors. And this is one of the components that is used in the system to figure out what a person is doing and deciding how to control the robot correspondingly. Now, since I said, okay, let's work with the robot, this is an example. It's difficult to perceive the quality, but I mean, the person is not making any effort. It's just touching the robot and lifting a little bit, and the robot knows the stresses, the articulatory stresses on the person, and therefore the robot itself is doing or finalizing the movement properly. This is another case where, of course, you can interpose an object like a box with a certain weight between the robot and the person. And again, you can build a controller on the robot that takes into account the fact that you have a way to be lifted, what is the optimal controller for the person to minimize articulatory stresses. I'm not entering into the details of this experiment because I must say the complication of the controller is fairly high here. Because there's this continuous exchange of forces, but basically we model the person like a robot. We have the complete model, and we model the dynamics of the object where the forces are exchanged, and then we try to optimize the entire thing, which is complicated, but entirely feasible in real time, as the robot is, you can see, is moving in real time. We also made it in such a way that the robot can do the same experiment with another robot, because of course you have exactly the same controller. It's entirely modular. Everything is modeled with a robot standard dynamics, and you can plug these components and create new controllers. Now, there's another thing that we can optimize, and apologize for this one. But I'll tell you the story. Is need to read it. You can these days parameterize everything about the robot. So the size, the masses, the length, everything that makes the body of the robot, and you can optimize also for the shape of the robot. So what we've done in those tasks where there's a collaborative weightlifting, we went also to optimize the size of the robot. And you say, okay, but the ICAB is given size, you cannot change it. Sure, but we can design a new robot. That was the idea. And in fact, we then moved to optimizing that big functional that is takes into account all the parameters of the robot, still maintaining or having a humanoid with legs, arms, hands, etc., but going through an optimization that eventually will figure out the best possible robot. And the best possible robot was this one, a slightly taller, slightly heavier ICAB in a sense, same technology. So joints are a bit bigger, but they're the same. The robot is now 30 kilos, became 65 kilos. It's a bit taller. It's 140, if I'm not mistaken. So from the point of view of the optimal weightlifting, joint weightlifting with a person. This is what we obtain from the optimization process. Why not a larger one? Probably because given the constraints on the technology that we have, it wasn't doable. So it was out of the envelope of the possibilities given by the motors and the parameters that we set into the robot. Anyway, this is called ergo cab, ergo from ergonomic iCab in a sense. And this is basically what we do in these days. You can see an older iCab and the new one walking here. And it's, just presentation of the robot is a grown-up version, not very, very different otherwise. What you can also see is that from this robot, we can now start building complicated behaviors. And these days, though, the complicated behaviors can also be learned. And now, the sensorized suit that we design comes to basically becomes the way you train the robot. And in fact, you can train from running teleoperation with the sensorized suit. So the same suit, the shoes that I mentioned, they're all data collections points or a means to actually collect data about what the person is doing. And if you teleoperate the robot, you can collect the same numbers from the robot. Therefore, you can have the person teaching the robot how to go through a task. And just since we're in the, let's say, in the time of deep learning, you can plug all these numbers into a big neural network, which is basically what we've done. Was far too easy to actually do it, in the sense that you just need a bit of GPUs and design a neural network that included here images, but also depth, but also movement. And in this case, there was also a speech interface. And the result is something like this one. These are experiments where the robot is doing stuff that was never programmed for. And so the say hi is being generated just because during teleoperation, when a person was doing like this, the operator was extending the hand, shaking hands. Similarly, when someone was getting closer to a robot with a box, the robot will extend the arms to carry the weight. And when you do this, the robot will come closer to you. I think it's kind of fascinating because, it's very simple. And there's no guarantee that it works because we have so many cases where the robot just goes crazy. But it's interesting as a possibility because indeed with the sensorized suit and shoes, we have a great opportunity to just collect enormous amounts of data that can be plugged into the robot. That's it. I think as a summary, what I can say is that the social, under development, there are a few nice messages to be taken from that type of interaction. The physical is getting super interesting because it can be the way we create robots that can interact with us very naturally. And the two things combined even better, although we haven't done it yet, but I think you can see the direction. This is, if when talking about the iCab, it was a lot of people that work on it. Designing the robots, you can imagine the number of engineers that were needed, software and doing the experiments, and students working on the experiments and so forth. This is the group that was doing human-robot interaction, social human-robot interaction, and this is yet the other group that was doing the teleoperation system. So probably like 200 people overall. I mean, the project's been running for 20 years now, so there's a lot of people that came, graduated, moved on, and I can proudly say that we have managed to train good students that are now in also very nice universities from US, London. One of the guys is DeepMind, running a group doing robotics there. I mean, there's certainly plethora of opportunities, and I'm proud of the people that work with us on the ICAP. Thank you.
Well, thank you very much for a very interesting talk. So we have like 15 minutes for questions. Do anyone have any question here? Any question?
Yes, Giorgio, I have a question about the experiment when you put a robot and the people put more attention to the robot. Maybe, well, that happens a lot because the people are surprised by the stuff that you are showing. How do you solve this? Maybe showing the robot before the experiment, or could you think?
They're typically naive users. They never use the robot. We tell them a story. There's a bit of preparation for each experiment. The story is non-informative with respect to the experiment because they had to stay naive. But we tell them, oh, look, this is a robot. The robot is programmed to do certain things. You know, there's a creation of certain expectations that have to be managed well. It depends on the experiment. So for other experiments, they're very simple. It's more just measuring the reaction irrespective of the fact that they know the robot. We also run experiments with roboticists, and of course, completely different story because they used to work with the robots, and also the background knowledge on how a robot works is so strong that it changes a bit the perception of the robot. Yeah, but indeed, it's part of the design of the experiments. Also, what you tell people before they go through the experiments itself.
Does the robot have any kind of world model, any kind of abstraction of its inputs?
Not really. If you're talking about the experiments where we doing more the autonomous behaviors on the robot, there's no world model in those. We have people, although we haven't integrated things, there are other groups that are working more on building full representations with, also the geometry of the environment being encoded into the system, but it's not yet part of what you saw here today.
Any other question here? I mean, en español pueden hacer traducción.
I can answer in English even if the question is...
Eduardo, bueno, mi pregunta la voy a hacer en español porque no sé, me es más cómodo. Y mi pregunta es cómo los humanos podemos cuidar mejor a los robots para evitar como en un futuro un daño regresivo, no sé cómo decirlo.
For the time being, no risk whatsoever because the robot is it's far too simple. I mean, there's no risk. I think that the question is more. I don't think there's a danger per se for this. What the robot does is entirely under control, programmed. The question is more that they have many of those. And the day those robots can be deployed for certain applications. Is it correct to have the robots there, and what may be the impact in society of those robots? Currently, at least in Europe, we're extremely worried about the fact that we're going to have to maintain about probably 20 to 25% of people out of the working age. So it's going to be huge numbers, and there's not enough hands to actually help those people. So, I mean, applications of robotics for healthcare are really, mainstream in the research environment because we think there may be a need. Similarly, in factories, there's a lack of manpower that is quite consistent, and people are going for, maybe we need efficiency generated through AI. Maybe we need robots to work on production, on manufacturing, and so forth. But that may be a situation where we may want to consider more the impact of robotics overall.
Any other question here or in the something else?
Oh, well.
When finding out the optimal robot configuration of the robot, when you show that it was being parameterized, what was the objective function? What method do you use?
That one was a genetic algorithm, although we switched to other systems at the moment. The latest development, we basically have the tasks, the environment, and the robot model does differentiable models so that we can basically run a gradient descent on that model. The parameters there, the objective function was the robot that minimizes the muscle skeletal stresses on the person on a task of joint weight lifting. So that was for that specific case. But I must say that it was a kind of an early attempt, and the new stuff is very powerful because you can use libraries, I don't know, JAX or libraries that allow you to design entire environments that are completely differentiable. So you can do gradient descent on those, including the entire model of the robot. So that's basically where we're going. It's huge simulations, but it gives concrete hints on how to design the robot next.
I think I have some questions online. One of the questions is, in sort of the short time, can robots be able to act as seen on many Hollywood films, mainly when it involves the use of AI? It's possible to.
Yeah, I mean, not necessarily. I mean, if you talk, it's kind of interesting, but if you talk to people, you've seen the Boston Dynamics videos recently, no? I mean, beautiful and moving incredibly well. And there's not much AI there in the controllers. Actually, Mark Ryder used to say, this is just good engineering, make it work. So it depends on what you expect to see from the robots. If you expect to see a robot that interacts and speaks to you, yeah, probably the new large language models are needed for that. But for everything else, I don't know. It's a mixture, I would say. Engineering, better neural networks, and combining the two things is probably, at least at the moment, the way we will go.
Thank you. Here, another.
In your opinion, why do we try so hard to create human-like robots? And I think about it because at the ADS case, would it be the same performance if the robot didn't seem so much like a human?
I think, why we do it, I think there's a question of fascination for human form, and we find it challenging to design something that behaves like us. On a more rational basis, there's a reason for if you need machines to work in the environment that has been designed for us, it's good to have hands, it's good to be able to walk, to climb stairs, to open doors, to use tools. So it's very, our entire world has been designed by us for us, and it's if we want machines to use this world, these tools, it's good to have a humanoid shape. That's a more of a reason. There are other reasons. Rodney Brooks used to say that if you want to design human-like intelligence, you need a human body. So that intelligence will only develop and learn like us because it's controlling a human body in a sense. And this may be, it's not too far from the truth, at least. Neuroscience is also finding a lot of the connection between perception and motion in our bodies is so much dependent on the structure of our body. So there may be a deeper reason why we like to develop human robots.
Here in the chat we have some interesting question. There is a way of to have access to one of your robots here in Mexico.
There's not, but there's. I mean, we never built a robot for a Mexican university. I mean, it's theoretically possible, but in practice, it didn't happen. So.
And also, the person asking for your contact.
Okay, sure. I mean, I'm happy to share the contact. Yeah.
Okay, thank you.
I think if you look for my name, you should find on page of the institute, and there's a form to send me an email.
We still have time for any other questions.
Well, I wanted to ask if there have been any studies that have studied, well, how different cohorts, different age cohorts interact with robots. For example, as you said, we have a population crisis because a lot of people are getting older and we need health robots. So, for example, for people who might not have grown up with tech, like my grandparents, how's that going to work? Is that going to be like, have there been studies about how we can make these robots more approachable to those kinds of people?
I mean, the stuff we're doing in human-robot interaction goes in the direction of not requiring any, you don't have to understand the technology very deeply. We're not there yet. So as you can imagine, I mean, the robots are still cranky. There's still complexity using a machine like that one. But I mean, the idea is that eventually you'll be able to teach the robot a new task just by showing the task. That's a paradigm that we're developing. So now we're doing it with teleoperation, which is complicated, but one day it's probably just visual demonstration will be enough to teach a new task to a robot.
Here in the chat, someone asked about if you think that culture or age or in general, I think some social aspects of the persons the robot interact can you influence the task or the solution of the task?
Probably yes. I will say that especially for a robot that is designed to interact with a person and then starts learning from the person, will probably develop a very specialized way of solving tasks and be maximally of support of that person. So I don't know. I think it's again it's a nice, fascinating topic of maybe one day we'll be selling robots that are all the same when they go out of the factory, and then they become they develop personalities because of interaction with people.
Well, any other question here? Yeah.
Again. You said that the robot has some problems with learning through vision, but not through motion capture.
Yeah.
Because that means that with this, again, implementation of the world model and self-representation of the embodiment, it could try to process the world into perceiving and understanding others' actions and understanding it just as well as a motion capture.
It's all plausible that we go to something like that. For now, it was a lot easier to use the teleoperation as a way to guide the robot through a task, and therefore we went through the easiest. But it's to be foreseen that at a certain point you can have just the robot standing there looking at set of actions or a task being performed by a person, inferring the movements and then building the complete sequence autonomously. I think it's plausible. It's not too far actually because you can build a model like that. I mean, a visual motor model can become part of one of the neural networks that we design in these days.
Thank you. We think we can move to the next presentation. Thank you very much.
Thank you.
For your
Thank
talk.
you.
And there's a.
Thank you very much, Professor.
Thank you. Thank you. Thank you very much. Thank you.
Ya vamos a pasar al siguiente ponente, ¿sale? Para que lo...
Bot computer visions and robotic manipulation products now deployed at Amazon's fulfillment network. He was previously professor of robotics and AI at the University of Birmingham in the United Kingdom, where he grew a cognitive robotics lab. He has published more than 100 scientific articles and received several prizes for his work. Then if Jeremy is there, you can start. Thank you very much for being here.
O sea, pero que no lo pueden grabar por YouTube. O sea, pero entonces como nada más se transmite por Zoom. Ok, pero ¿quién está haciendo la transmisión? Perdón. Ah, caray, no, es que digo, yo sí le había dicho que era en línea y que se iba a transmitir por todos los canales. No me había mencionado que no se pudiera transmitir por YouTube.
Pedimos un momentito de espera, por favor.
Hey, nada más que, ¿está ahorita contigo en Zoom? ¿Me puedes contactar con él directamente por Zoom, por favor? Ok, gracias.
Les pedimos un momento de espera. También hay galletas y café aquí en la sala de al lado, si alguien gusta pasar. Aquí al lado.
Ah, yo sí.
Lo que esperamos también.
Que necesitan asistencia para comer la constancia. Hay que registrarse por cada conferencia.
Gracias. Permiso. Importante. A ver, no le quitamos que jugar.
Hello. Should I start speaking or am I waiting for an introduction?
Yes, I already read the introduction, I think, but thank you very much. We can start. Entonces, ahora sí vamos a comenzar. Sí, están aquí. Well, this talk is called Robotic Manipulation at Amazon by Jeremy Wyatt. Then, if you, Jeremy, can start. First of all, thank you for being here, and you can start wherever you want.
Okay, thanks very much. So my name's Jeremy Wyatt. I'm a senior principal applied scientist at Amazon, and I work in fulfillment technologies and robotics, which is the organization which is responsible. If you order something from the Amazon website in any country in the world, we're the people who are responsible for ensuring that that item is fulfilled and delivered to you correctly. So we're part of worldwide operations. And obviously, as part of the work that we're doing, we're increasing the amount of automation, and Amazon provides a very interesting, if you're a scientist, but also a very important set of customer opportunities if you're an engineer, and I'm both. So very interesting scientific problems and manipulation, and also wonderful applications. And there's a whole series of graded applications, both in computer vision, in support of robotic manipulation, and in manipulation systems themselves. And I'm going to talk about these. I'm going to talk about some of the products that we've built and in the ways that these are benefiting on customers. First of all, though, I'm going to start because prior to Amazon, to give you an idea of the contrast between academia and industry, which was that previously, when I was working at Birmingham in Europe, I was working on robot manipulation there, and we were very pleased with the work that we did at the time. And I want to show you just a quick clip of that work, just to give you a sense of where we were in sort of around 2016, just prior to joining Amazon. So this is going to be a clip of a set of robot arms that they're taking point cloud images of objects, and then they're planning dexterous grasps. And this was state-of-the-art work at the time. And you will note that the point clouds, which are marked in red, are often very fragmentary, and yet the robot's able to plan dexterous full contact grasps. We show a couple of different grasps from a couple of different subsystems. Some of these grasps succeed and some of them fail. And what was powerful about this work was that although it doesn't always work, the robot is here generating grasps for objects that it has never seen, for objects of which it has no model. And in particular, the number of training grasps that the system had in order to be able to pick was very, very small. So it implemented a system that we call one-shot learning, so that the robot would essentially learn a whole variety of grasps from a very, very small number of training grasps. And so we were happy with this. We thought this was great. And then I came and an interviewed at Amazon, and I suddenly realized that this kind of work was not going to scale. And I want to talk to you about why and about how we tackle those problems. So the reality, I mean, that short movie clip showed all of the objects being singulated. The reality is actually something like this. This is what you would see if you were a robot in a fulfillment center, and you had to either stow or pick items. This is a shot of what we call a pod. Pods.
Sorry to interrupt, but you're not showing any presentation. I don't know if this is.
I see. Then I think we have to go back and check. My apologies to the audience.
Thank you.
Can we go back to the backstage and check this out and figure out what's going on here before we come back?
Yeah, I think you.
I mean, I think this is an issue. I think this is an issue probably on the other side, and so we're going to have to fix that issue. I'm not going to be able to fix that issue from my side.
Okay, let me check, and I will tell you if we can correct this issue. ahí no sé si alguien puede otorgar permisos. Es que me parece que no tiene permisos para compartir. No, así nos podrían dar permisos para compartir ahí.
Me parece que ya está listo.
It seems that you can share now. Jeremy? Please check if you can share a presentation now. It seems like it's already. Hello, hello. You can hear me? You can hear me, Jeremy?
Anda en el backstage. Un momento en lo que regresa.
Ok, nosotros esperamos. Hello, Jeremy, you can hear me? You can share now your presentation.
Can you now see my screen?
Not yet.
I'm sharing the screen. Let me try again here. How about this? Does that work?
Yeah, it works. Yeah, we can see it. Thank you.
Okay. Okay. All right. So I'd already given a brief overview. Let me just flick through this movie that you didn't see. So this was the movie I was talking about when I was talking about the kind of work that we were doing in 2016. So this is a shot of a series of grasps performed by robots with slightly different learned models. And the grasps, as you can see, are of objects that have very little what we call point cloud recovery. So the red dots in the screen, that is what it knows, the robot knows about the surface of the object, and it plans its grasp given that and that information alone. And what was powerful about this work, as I said before, was that the robot was able to plan grasps with very little information for novel objects and objects it had never seen before, and it was learning dexterous grasp, so it's learning all of the contact placements of the fingers and the finger joints, and it's doing that learning from a very small number of grasps. So in our initial paper in IJRR, we had maybe 5 grasps that we used. I think we used up to 13 or 14 grasps in the subsequent papers, and we were very happy with this. We thought this was great. And then when I transferred over to Amazon, I discovered that there were a number of things in this. We thought perhaps you could use this in industry, and you can't. And this is really a lesson about the difference between industry and academia. All of the objects here are singulated, as I said before. So now if we switch over and see what we see in reality, this is what it looks like. This is a pod. So this is the main storage device that we have. So these pods they're made of cotton fabric. They're hung on metal frames. And then we have mobile robots that we call drive units that pick up. The pods are actually much bigger than this. It's just a picture of a section of the pod. And they pick up the pods and they bring them to pickers or stowers. So pickers are people who pick the orders for you, and stowers are the people who put items into the pods. And you can see here that the manipulation problem is much harder. There are many objects. The scene is cluttered. We have these elastic bands across the front of the pod, which means that you cannot, directly access the objects. And also, it's the case that the variety of objects that we have, although we did have this in the movie before, these are all objects that maybe the system will not have seen before, because we have many, many new objects entering the system every day. So this is the reality of manipulation in industry, and it's much, much harder, and it's much less forgiving of errors. So the error rates that we must have are very, very low. So there are several reasons why tackling these problems is really compelling. So the first of all is scale. we call a particular item, a particular type of item within our catalog, an ASIN. So think of it as like an Amazon standard identification number. And there are billions of these within the network. And there are many, many packages. And we serve billions of these every year. There's also a huge amount of variability because there's hundreds of millions of unique products. And that variability makes, in comparison with, say, for example, picking the parts in a car plant where you have CAD models and you have a relatively limited range of parts, that item variability is really challenging. The other thing is we also have process variability. As you'll see, we have tasks of varying degrees of difficulty, from the relatively, I wouldn't say easy, but the relatively within the current bounds of technology, all the way to really pushing the forefront. And the other thing is perfection and quality, which is that we want to get it right every time. It's simply not acceptable to us to deliver a damaged item to a customer or to send the wrong item to a customer. We have to pick the right item. We have to pick it in the right way. To do that, the first thing that we have to do is we have to understand the items. And there are a couple of technologies that we've invented and deployed independently that allow us to understand much better the items in our fulfillment centers, particularly for the purposes of robot manipulation. I'm going to describe very quickly a couple of those now. The first is the ability to identify an item. And when I say identify an item, so it's what we call, again, an ASIN, or you might call in another logistics setting a SKU, a particular stock unit. So that, for example, it could be a particular phone brand in a particular box, and we want to pick that item. We want to identify that and discriminate it from other similar items, perhaps other mobile phones or other items that look similar or in similar packaging. So the way that we did that is essentially what we do, without going into too much detail, is we create effectively a kind of what we call a digital fingerprint for the item. So we'll take RGB imagery of the item, we'll take depth imagery of the item to recover its surface geometry, and then we're going to calculate visual features. We might extract other features. So, for example, we might explicitly extract text. We will infer the dimensions of the item, and then we're going to combine all of these. And the way that we do this is we use methods called embeddings. So these are methods that allow us, with a model, to learn a low-dimensional or lower-dimensional representation of the image of the item. So whereas the initial image might be millions of pixels, the lower dimensional representation might have hundreds of dimensions, and it might be hundreds of dimensions. And then we're able to then present a set of new items. So, for example, we will be picking items not from all of the possible items in the catalog or from all the items in the fulfillment center in our warehouse, but instead we'll be picking items perhaps from a particular container, such as a tote. And so as we pull the items out one by one, we will seek to recognize the items. But in fact, we don't have to recognize them, as I said, from every single item. We actually just have to discriminate them from the other items in the tote. So in other words, the manifest of the tote is known, and we have to decide which of those items in the tote is the item that we're looking at right now. So here we can see the headphones, and we want to be able to identify the headphones that we have just seen. Perhaps it's been presented at a tray because somebody's just picked the item out of the tote and put it into a tray, so the item is singulated. And then we want to know, is that item the right item? And we can build a product just from that simple ability. And we built a system that can do this. It can do it to a very high degree of reliability. And with that, we are able to check items. We've built an imaging station, and that imaging station is able to tell us whether or not the item that has been picked and put in the tray is in fact the item that the system expects, the item that the customer ordered. And then that means that we have the ability to go check the item. And if it's wrong, we can then take the item, we can take the tray that it's in and shoot it off to an associate, and the associate can very quickly check whether it's the correct item. So we send it suspicious items. And if the item is indeed the right item, it can be put back into the flow very quickly. And if it's the wrong item, then it can be taken out and the new item can be picked. And that saves us a lot of time because we discover early that we've got the wrong items. And this is an image of the imaging stations, and you can see how quickly these trays of items are going through. It's thousands and thousands of trays every hour on every single one of these conveyance lines. And then we can add other things to this kind of product, which are also going to be helpful to us in robot manipulation. So, for example, one of the things that we want to do is we want to make sure that we never ship damaged items to customers. And so in addition to being able to recognize an item, and particularly once you know what the item is, it's easier to detect and to determine whether there's any damage to the item. So here's an example of a package, and our vision system has determined that this is a damage detection. So it's a separate vision system, but running on the same rig. It's determined that this is a damaged package, and it also is able to highlight where the damaged areas are. And again, we can do this by comparing instances of that product, what it should look like, and then what it actually looks like in the tray. And the system essentially detects in a quite a generalized way differences, and we're therefore able to detect. And we talked about this in, I think it was in an article in the press, in the Wall Street Journal, that at the time of publication of that article, we were able to detect 3 times as much actual damaged, 3 times the number of damaged items than were associates operating in our buildings, because our damage detection system is just focused on damage, whereas our associates have to do many different tasks. And so by having a system that is just able to focus on this one task, we're able to release our associates to concern themselves with the other things that they do that really matter. And so we get not only a better result for the customer, but we also get less cognitive load on our associates. So with those systems, we've actually put those into production, and those run around the world every day, and they detect, that you get the right item, and they make sure that you get a non-damaged item. Now I want to talk a little bit about taking these kinds of systems and putting them into manipulation. The simplest, or the first tasks that we tackled, were what we call package pick and place systems. So this is a system called Robin, stands for Robot Induct, and we built this system starting in 2019. And Robin is a system that picks packages for sortation within sortation buildings or within fulfillment centers. And so as you can see here, it's a suction device. It's presented with a large number of packages on a piece of conveyance, and it has to do a visual segmentation of the packages on the conveyance. It then has to decide where to pick, and it has to also pick so that it minimizes the chance, for example, that it picks 2 packages. And then it has to reorientate the package. It has to identify it through the barcode on the package, and then it has to put it down onto the robot. So it's not a trivial task, and there have to be several systems in place to make sure that we've done it correctly. So, for example, we look at the drive units, the robots that it places it on afterwards, to make sure that we've only placed one package, but that we have placed, a package on the robot. And we have several other error detection systems that are also machine learned systems. And one of the things that we learned is by doing these is that we have to apply a technique that we call continual learning, which means that what we do is over time, we will see large numbers of scenes, and sometimes the robot will not be able to pick, or sometimes the robot will pick 2 packages, and we can detect that later. And then what we can do is we can find those scenes where we believe that the robot has made an error, and there's an exception, and we can ship those images for re-annotation by humans, such that the human will annotate the image and mark out what the different objects are in the image and say what different kinds of material to be handled they are. Is it a bag? Is it a box? It is a poly bag? Is it a Jiffy envelope? And then over time, we can then take those annotated images and then retrain our system, so that we're always retraining our system on the hard cases on which it's failing, plus some random set of other cases. And then with our new model, we can do what's called an A/B test, where we're testing at scale in our network the new model against the old model, and we see, does it actually improve performance? And in fact, it does. And this technique of continual learning is critical to maintaining the performance of our systems in production. A good example of that is this scene. So this was a scene from a sortation center that we had in the UK. And we offer a service called Ship with Amazon. And Ship with Amazon means that people who don't necessarily sell directly through Amazon can still ship their goods through our distribution network, which is a great service. But it means that the variety of objects, packages that we might see is much greater. And this is a particularly challenging scene because all of the packages are black polythene bags, which are very shiny. So they were initially challenging for the system to perform, but via the continual learning method, we were able to very quickly relearn so that the performance on these kinds of packages was able to be improved quickly, and we were able to kind of keep production flowing. And you can only do that if you have these kinds of continual learning systems in place. And this system is there's more than 1,000 robots in the world. using this right now in our network, and we're picking tens of millions of packages every week with that. So it's handling a large part of the or a significant part of the workload. We don't just pick packages. As I talked before, we also have this idea of product, which in Amazon lingo we call ASINs. And one of the things that we would like to do is to be able to singulate or to organize ASINs. And one of the places that we store ASINs is in totes. And so one of the sort of a fundamental operation for us is to be able to take all of the items out of one tote and to put them into a new tote. And this is part of a system. This is a system called Sparrow that we released we gave press releases on a couple of years ago. And one of the places that we've done experimental deployments of Sparrow, although we're now using it in a production setting for in our new highly automated fulfillment center in Louisiana called SHV1. But this is a shot of an early deployment of Sparrow, where what you're doing is you're singulating the items into those totes, out of a tote into a single tray, and it's those single trays that then go through our imaging system to check that we've picked the right item. Now, the thing about that picking system is that picking system is picking all of the items individually, but it's using suction cup. However, there are some other ways that we can pick and manipulate. And so we've also been doing research that we've released in our science blog articles, if you want to go read about them. And this is an example of doing pinch gripping. And this is a particularly interesting system because here, what we were interested in doing was trying to really push the envelope with pinch gripping. And so here what we do is, in order to make the pinch gripping more feasible, we have a slightly compliant surface on which the objects sit. We're now not picking from a tote, we're picking from this disordered pile. But what we're doing is, in real time, we're resegmenting the image very, very frequently. And then what we're also doing is we're incorporating state-of-the-art implementations of trajectory optimization algorithms so that the robot is actually deciding how to move on the fly. And while it's moving, it's taking a picture then of the scene, and then it's replanning where to grasp and where to pick. So this movie is not speeded up. So the planning happens in tens of milliseconds and the image processing in maybe a few hundred milliseconds. So this is this picking system's picking at around just over 1,000 units an hour, which is high speed, even by our standards. But this is a demonstration system. This isn't a production system. And if we're going to do manipulation with contact manipulation, not using suction, such that we can handle those very high density storage cases, that's going to be really challenging. And that's what I want to talk about next. Okay, I appreciate that I'm trying to go quickly so that we can maybe catch up some of the time that we've lost. The next task I want to talk about is, in a sense, the task that was on the second slide, that picture I showed you of the Amazon pods, very densely stowed. We would like to be able to automate that process, and we are going to be releasing some information. I mean, we've already, everything I've shown you, we've released in public somewhere at some point, but we're going to be making some more announcements about this in the next few weeks. But it's a problem we call stow. So this is the problem of putting items. We have items, they come in totes. So this is on the inbound path into our fulfillment center. And there you can see a full pod on the left-hand side with the man standing on the steps in order to make sure that he can safely stow an item into the top level bins. And to give you an idea about how challenging the manipulation task is even for humans, I'm going to play you a short movie of a person performing this task. So here you can see she brings in a new pod. She now clicks on a tote that she's just pulled something out from. She then gets up onto the ladder to stow safely. She moves the elastic band. She's spotted where she's had to make a decision about where to stow it. She's now having to rearrange the contents of the bin in order to fit the new item in. And now she's also going to do this a second time. Back up the steps. That's a really, really challenging manipulation task. That looks much harder than either the tote rearrangement or the picking from piles. So how on earth do you think that we would be able to tackle this? Well, in fact, we have, and we've made some progress, and I'm going to show you that progress. And we have talked about this publicly before. So this is a short movie, and then I'm going to show you maybe some more results, which is, this is a system, we call it Vulcan. And Vulcan is a system built around a dexterous robot that is able to use AI to predict where to make space within the pod. So we image the pods, find the spaces, we find out the depth. We are then able to estimate where hidden surfaces are. We have the ability, this is not the method we use now, this is an older movie, but we separate out the bands. And then we have a device that enables us to manipulate in very simple but effective ways the items within the pod, and then to shoot out the item using a pair of conveyor belts. And so that's an example of a very simple stow. Here's an example of not a simple stow, it's actually quite a complex stow. And at that point, when we released this movie, which you can find on our science blog pages, we've done about 15,000 stows, and we're at significantly more than that now. So I want to now show you a quick movie of where we were about a year and a half later. So this is a fulfillment center in Spokane, and we have multiple cells all together. And I'm going to show you some of the really challenging stows that we can do with this system. What's happening here is, I'm sure when Giorgio was talking that he talked about the importance of compliance and how that in manipulation is critical. It's particularly critical in this kind of contact manipulation. These are some of the most challenging compliant manipulation tasks or instances I've seen in my career, where it has to make predictions about how much it can squeeze up the space, how much space it's going to be able to create, and it has to maneuver in that blade in just the right way, as you can see there, in order to flip up an item, squeeze it to the side. And some of these blade insertions are really challenging, and some of the objects are really only just going to fit inside that pod, and yet it's able to do it. And this requires a really careful coordination of the AI for the perception, the compliant control for the manipulation. And so the robot, when I say compliant control, just to be clear, what I mean is that the robot has a sense of a simple, but a sense of touch. So it's able to feel contacts, and it's able to feel some of the forces and sense the forces that it encounters. And it uses that for performance improvement and error recovery. So these are some of the extremely difficult but challenging operations we can do today. And that's me wrapped up. So although we started late, I've been able to get through the material, finishing just on time. So that gives us the right amount of time for questions. Thank you.
Yeah, thank you very much. Well, we have some time for questions. Any question here?
Well, my question is, when ordering from Amazon, there have been several instances where I've gotten multiple of what I ordered. Why does that happen? Is that something that happens when the package is being sorted by humans or by robots?
So there can be, so defects do occur. They're rare, but they do occur. So one of these, and actually our damage detection system now detects these. So there's two instances I can talk about. One of which is what we call multi-pack. So this is when incorrectly in the system for some reason, and it could be because the encoding by, for example, if you've bought it through Fulfilled by Amazon, maybe the original barcode on the item was wrong. We've seen those instances. So even when we receive it into the network, we identify the item through the barcode, and then it turns into the wrong item. But one particular instance of that is that a multi-pack, so let's suppose you had a set of Tetra Packs, maybe of, I don't know, soya milk or something like that, and it thinks that the multi-pack is a single pack. And so the system's encoded it wrongly for some reason. And so that means that then when we ship it to you, we're shipping you, 6 Tetra Packs rather than maybe 1 Tetra Pack, which is what you wanted. And so in our damage detection system, what we're able to do now, the one that I showed you that detected the damage in the bags, it is general enough that it's also able to detect when, the item should be a single Tetra Pack, but it's actually multiples. And we can also find cases where we find we want to send you a multiple, but it's what we call a broken set. So this is when, for some reason, maybe it was meant to be a pack of 6, and actually one of those items has come apart, so it's no longer there. And so we also want to make sure that we don't send you one item too few, just as much as we don't want to send you 5 items too many. And so that damage detection system on the way out, using those imaging stations, is able to detect that. And as I said, it's able to detect about 3 times the amount of real faulty orders that our associates were able to detect before, and we're using that in an increasing number of fulfillment centers. So I'm hoping that you will not be receiving another erroneous item.
Any other question? Puede ser en español también, podemos traducir si quieren. Question? Nobody in the chat?
Hi, I have a question mainly about manipulating task where you show this difficult scenario and there is this arm trying to push the items to the side and then the other one inside and they are soft. What is the
Yes.
kind of technology that is involved in designing the hand with the proper force to do that and at the same time the compliance?
Well, you might have noticed that the sharp-eyed amongst you will have noticed that the actual robot arm we're using is that's a universal robotics arm, right? So that's a not a standard industrial arm, but it's an arm that some people refer to them as cobots. And that particular design of arm, and there are many others, not just universal, is able to execute a kind of control called admittance control. So that's a kind of compliant control. And that admittance control, once we've set a series of target waypoints for the arm and the manipulator, is able to execute them with a sense of touch, so that if it encounters an object along the way, it will adjust the motions. The other parts of the technology in designing the EOT, I mean, obviously you will have noticed we designed not a general purpose EOT, we designed an EOT for that particular task. And that's one of the techniques that you have to engage in if you want to increase the reliability of your system. I don't think I can tell you specific things about why that EOT is designed in that way. I mean, you can sort of see intuitively that having the blade pushing items to the side is a relatively simple way, because the blade's nice and thin. You can get it into even quite a densely populated bin, and then you can move it aside. And we do have a force sensor very close, not at the tip of the blade, but as oh, hello, am I still here?
Yes, you're still there.
Oh, okay. I thought something had gone wrong. My screen changed, and so you can see that when the blade is inserted, we do have a sense of force. So we have a we'll have like force torque, 6-axis force torque sensors, or other. Maybe it's not even 6. Maybe it's 2, and they will detect the force being applied at the tip of the blade. But to do that, one of the tricks that you need to execute in control is that you need to make sure there's as little uncontrolled mass between the last force torque sensor and the point of contact. So you want to have as little uncontrolled mass as possible. So you try to get that force torque sensor as close to the place of interaction and have as little mass as possible. And that's actually critical. The other part of it is that you need to maximize your bandwidth, and it can be your control bandwidth, and it can be quite challenging using current technologies to make sure that you have the control bandwidth that you would like to have to get the speeds that you would like with your robot arm, while also making it completely safe and never, you don't want to ever damage an item, for example, by pushing the blade into it and then crushing the item, or by hitting the metal frame of the pod and then triggering an e-stop. Those are things that we would like to avoid, if at all possible. So that control bandwidth is the third element. So you can use a combination of both your own technological invention and the existing things that are available on the market.
Great. So just to confirm, then the initial scenario where the girl is taking from the original tray, pushing the button, going upstairs, and then moving all the packages, does it mean that this arm can only sort like some of the cases of rearranging, or could it actually put the package inside the same scenario that the girl was using?
Hers was particularly challenging because the packages were oversized for the bin. So strictly speaking, we would say that might be I mean, it was difficult to see whether, if she'd have rearranged it a little bit more, whether she could have had the packages standing upright in the bin. Normally, what we say, we have this notion of what we call bin etiquette, which is that you should put a package in a bin that can stand upright like a book. So we organize everything side to side so that the thin edge is the edge that's facing you. And so you could make the case in that instance that ideally you would not stow that item in such a short bin, because if you although you probably didn't notice this, our pods, we have bins of all different sizes. And so one of the things that actually an automated system is really good at is making choices, because it knows what pods are coming about, by imaging the pods, and then it can make choices about planning where to put which items in which bin, in which pod. And so it can avoid those problems. So it's less that we would be able to handle that case having chosen that bin. I don't think that we would. I think that you're not going to get to human levels of dexterity. Instead, what you do is you do intelligent allocation, so that you're doing the things that AI systems do well at scale, and then with the control and the robot, you're trying to get as close as you can to the performance of the human, even though you're not going to replicate the true range of dexterity of human manipulation. That's not the aim here. The aim is to be good enough.
All right, thank you very much.
Thank you. Another question here.
Thank you. This is maybe a more administrative question. Like, how long does it take to build these robots, and how many robots have you built before the final instance of it? And how big is the team of engineers that have these projects to do?
Okay, so I'm going to be careful because I don't want to reveal anything that might be regarded as non-public information. I think that one of the slogans that we had in our team was, the compile time for software is a lot better than the compile time for hardware. All right. The compile time, the time it takes to design a piece of hardware, source all the parts, assemble it, test it, and then go back around that loop is weeks, even if you're very, very fast. And it can be months, to move between iterations, easily months. So you're looking at, and then obviously we want to make sure that we're building the right product. So our development programs can last years to go from initial technological concepts to products. But let me put it like this. I joined Amazon in September of 2018, and we made progress on a program that had been running about a year on how to start to do manipulation. And by the middle of 2019, we already had very early prototype systems working within production facilities, albeit not serving a great deal of serving very small numbers of customer orders or customer packages. But by the following year, we'd scaled that from one robot to 20, and the following year we scaled that from 20 to 700. So it takes a long time to develop, and hardware is really challenging to revise quickly. You have to be patient and you have to build the right thing. But once you're iterating, you can be faster, and once you're scaling, you can be faster. In terms of the sizes of the teams, I mean, I couldn't talk specifically to the sizes of the teams for particular products. With certain things, it could be, I've seen great products. I mean, the damage detection product, we started with a very small team. I can't say how small, but very small. But overall, I mean, I work as part of an organization that's thousands of people, right? But we're responsible not just for the development, but for all of the deployment and maintenance and all of the different aspects of our robotics work across the world. So the teams are substantial, and it's a very different level of resourcing and a very different level of ambition and impact to the work that I was able to do as a professor in a university, for sure.
Thank you. We have a few questions in the chat. Manuel is asking if you can expand on the use of the embeddings as a representation of the items, and if you can talk about the method is used to capture the item description into the embeddings.
Sorry, what was the second part of the question?
If you can talk a little about which method is used to capture the item descriptions into the embeddings of the items.
Well, I can talk in general about embeddings. I mean, work on embeddings is quite well known within AI. So an embedding is essentially what we're doing is we take an image or, an input vector, and then we push it through a network whereby at some point in the network, we're going to have a bottleneck. And that bottleneck is going to be the low dimensional representation that we would like to achieve. And then what we can do is we then will have a loss function, or we can have a variety of loss functions on the output side. And what we're trying to do is we're typically trying to train the model so that the embedding, and what an embedding is essentially, is that we want things that are similar in appearance to be close to one another, or that are the same item, actually, maybe from different appearances. But we want the same, different images of the same item to be very close to one another in this, say, 300-dimensional space. So we train the embedding so that that happens, so that we bring the same item, these sit close to one another in the space, and then we have items that are separate. We push them apart in the space. And there are various techniques, that are well known when in learning embedding. So, for example, mining hard cases, using triplet loss, trying a variety of different loss functions on the output side to try to maximize the sort of the properties of the embedding that you would like to see. And then what you do is then when you're trying to find a solution, what you do is you put an input image here, and maybe it's your manifest image and then your gallery image. So the image that you're querying is here, and you run that through the network and you find out where it is in the space. And then you put all of your manifest images of your manifest items through. And then it's a nearest neighbor problem. So you're just saying, hey, which is the closest item to me in this 300-dimensional space? So that's a sort of a basic embedding concept, and that's very widely used in computer vision for recognition. There's nothing particularly novel about that, but obviously there were details about how we train it at scale and so on that are proprietary and that I can't talk about.
Thank you very much. And someone else?
Hi. I was wondering if it's possible to know the name of the research papers that will be published by this work.
Sorry, is it possible to know the name of what?
Of the research papers.
Recording stopped.
We so in terms of research papers, we only publish a little bit. We're not, my job at Amazon, which I love, is not to publish papers. My job is to invent new technologies that benefit millions of people across the world every day. We have had some publications. You can go, if you want to understand more about our work, you can go to the Amazon Science blog. There's Amazon Science. We have a series of web pages also where I think under each researcher you can Google a particular person's name and you can find out publications that they've made while they've been at Amazon. I typically don't publish while I'm at Amazon. As I said, I like to build products now. So you can find the names of researchers in different bits of Amazon who do publish on Amazon Science. So if you Google Amazon Science and robots, I'm sure that you will find the right link, and then you can find out more. And then there are, from those publications, you can go. So, for example, we had a paper in IROS a couple of years ago where we talked about the Robin system and how we actually did continual learning to improve our grasping over time. So there's a paper in I think it's IROS. It's a short paper, but it's a paper in IROS.
We have another question.
Hi, talking about the packaging lines in a close future, we are thinking replace all the human work, or always we need humans.
There's a very simple answer to that. We always need humans. It's always a combination, and that's always been the way that automation has worked. We will always need humans because humans are wonderful exception handlers. We're wonderfully creative. We can solve problems that are still a long way from being solvable with AI. And even if, as we eat each piece of the puzzle with automation, we will always need people to supervise those systems. And we have no shortage. We always have a demand for more people in our company.
Okay, thank you. We have time for another question. Is anyone here? I think we had in the chat. We have a question. Could this technology be used to suggest new kinds of package and covers that optimize the resources used in the storage and distribution of the products?
Sorry, you're going to have to repeat that to me. I'm
Sorry.
struggling to see it.
Could this technology be used to suggest new kinds of package and covers that optimize the resources used in the storage and distribution of the products?
Oh, I see. Can we optimize the packaging and the storage with the robots? That's a really interesting question. We certainly put a lot of effort into optimizing our packaging for other reasons, such as, for example, for sustainability purposes. But one of the consequences of that is that we find that there are sometimes optimizations that we might make for those reasons that then might make things sometimes harder or sometimes easier from an automation perspective. So when you're optimizing your packaging, you want to optimize your packaging for several things. You want to pack the minimum amount of air. You want to make the package as robust as you can, but no more bulky than necessary in order to protect the item. You want to make it as pickable as possible. And all of these are in tension with one another. So we're constantly optimizing our package mix and our package designs to try to get the best out in terms of sustainability and size and manipulability. But yeah, so I think that we do that in tandem with robotics. So we take robotics, we take an increasing amount of, we take the robotics into account, but the robotics always has to work with the package mix that we have, and the packages change over time. So you can't design your robot system to just work with a particular package type or a particular set of package types. Do we have time for one more question, or are we completely out now?
I don't know if we have the time for a final question. You know what? I think in the chat we have a question. How much time does it take to build a robot like Robin or Sparrow?
Oh, well, I think I answered that question before, or at least I tried to. So let me repeat. So we were working on predecessors of Sparrow in 2018 when I arrived, and we released Sparrow. I think we talked about it in 2022. We went public with it. That didn't mean it wasn't working before, but we went public with it then. And the Robin, we were able to launch that in 2020 at a network scale, end of 2020, we began to launch at a network scale, and we started that in 2019. So sort of within 2.5 years, we'd sort of gone from not having Robin to having Robin in multiple places.
Thank you. We think we finish here. Thank you very much for this amazing work you're doing. Thank you for being here. We can give an applause.
Thanks very much. It was really a pleasure to come and talk, and thank you very much for inviting me.
Con OSI Visión, casos de éxito y detección de cáncer, que es presentada por Francisco Flamenco Andrade y Eric Israel Agapito Bautista. Eric es un joven profesional originario de la Ciudad de México, con sólida experiencia en el desarrollo de soluciones para clientes. Ha trabajado en proyectos que integran inteligencia artificial, especialmente en la industria retail, donde propuso una innovadora solución para la mejora de ventas cruzadas y micropersonalización en una de las principales cadenas del país. Además, cuenta con experiencia en el desarrollo y participación de proyectos educativos enfocados en la enseñanza de los principios de inteligencia artificial. Francisco es consultor de retail en Oracle, especializado en el desarrollo de soluciones tecnológicas como parte de su formación en el Tecnológico de Monterrey. Ha trabajado con IA, explorando su aplicación en la optimización de procesos y la innovación empresarial. En Oracle ha diseñado e implementado soluciones integrales con inteligencia artificial, impulsado la transformación digital en empresas líderes de México, y su experiencia abarca desde la automatización de procesos hasta el desarrollo de modelos inteligentes que mejoran la eficiencia y la toma de decisiones en distintos sectores. Entonces, les agradezco que estén aquí, que acepten la invitación y les paso la palabra.
Pues primero que nada, queremos dar un... no soy yo. Bueno, primero que nada, pues muchísimo gusto de estar aquí presentando esto y primero que nada queremos dar también un preámbulo de lo que vamos a estar más o menos platicando el día de hoy, que pues tiene mucho que ver con los servicios que oferta Oracle, en especial la parte de Oracle Cloud Infrastructure. Como sabemos, pues es un desafío hoy en día tener el poder de cómputo necesario para poder correr machine learning o servicios de inteligencia artificial de manera física. Por eso, los servicios de Oracle Cloud Infrastructure, pues tenemos acceso remoto a servicios de cómputo de instancias de GPU y TPUs que van a permitir realmente potenciar estos modelos para que no necesitemos tener un equipo que puede costar incluso millones de dólares y lo podamos utilizar en la nube. Oracle Cloud Infrastructure tiene seguridad y creo que una parte muy importante para el aspecto de inteligencia artificial es la escalabilidad con la que contamos. Vamos a platicar un poco de esto más adelante, pero por ahora pues queremos enseñarles pues para aprovechar con la inteligencia artificial y el machine learning, realmente facilita el entrenamiento de estos modelos complejos y las soluciones que tenemos, que va a contarnos un poco más Erika al ratito, juntan a hacer algo holístico que permite potenciar la inteligencia artificial en el futuro.
Vale. Pues muchas gracias, mi Fran. En este caso, yo les voy a estar hablando un poco de los servicios que tenemos en OSI. OSI es Oracle Cloud Infrastructure, como mencionó Fran, es nuestra nube. Tenemos muchos servicios de inteligencia artificial. Si los pueden ver aquí. Tenemos servicios desde OSI Digital Assist, es decir, tenemos sistemas que pueden cargar modelos LLM, podemos crear chatbots de manera muy rápida. También tenemos servicios de OSI Language, es decir, le pueden pasar un texto, un documento, detecta, no sé, el lenguaje, hace una traducción automática, puede extraer partes importantes del texto. También tenemos, tenemos OC Anomaly Detection. Esto sirve mucho como, no sé, bueno, vamos a hablar más aparte de esto, pero sirve para la detección de anomalías, dígase, no sé, en retail, manufactura, etcétera, etcétera. También tenemos servicios más dedicados a la infraestructura, que eso va a ser un tema que vamos a hablar un poco más a fondo. Ahora, bueno, aquí les traigo uno. Esto es un SQL Agent que hicimos con OC Digital Assist. Básicamente podemos conectarlo a tablas de, no sé, algún servicio que ustedes tengan y podemos conectarlo para que ustedes nomás les pidan, no sé, el query de la información y automáticamente el agente les va a dar el query para que lo peguen o inclusive ya la información de que ustedes quieran sin tener que haber programado el query. Cabe recalcar que tenemos servicios como Apex. Apex, podemos poner esto, es un asistente virtual como Copilot que puede ayudarlos a la generación de código, inclusive pueden escribirle a la gente en Apex y decirle, no sé, yo quiero una aplicación con estas características y les puede dar ya la aplicación con los frames casi completos. Bien. En este caso nos vamos a centrar mucho en OC Vision. OC Vision es un modelo de reconocimiento de imágenes estandarizado customizable. El sistema está diseñado ya sea para labels, es decir, podemos entrenarlo para que pueda detectar texto en un entorno, inclusive objetos, anomalías, puntos de interés. Ejemplo, no sé, que ustedes quieran entrenar a OC Vision para que detecte cierto texto cuando pasa en un video, podemos hacerlo. Esto es importante, sí. Hemos visto que a lo largo de que la industria está creciendo, tanto la industria de retail, manufactura, etcétera, etcétera, cada día más necesitan estos sistemas que les permita detectar anomalías o les permita, no sé, entrenar para ciertas situaciones. Entonces hemos visto que esto es algo que se está volviendo cada día más importante. Bien. En este caso aquí trajimos una demo. OC Vision lo podemos conectar con un sistema de video. En este caso OC Vision, como pueden ver, está detectando los nombres, está detectando también los objetos. También OC Vision se puede entrenar para detectar objetos específicos. Ustedes pueden entrenar el modelo, no sé, para que entrene de que detecte solo coches o inclusive tenemos face recognition aquí. Podemos hacer que detecte caras, que cuente cuántas personas hay en un área por cualquier cosa que se necesiten. Y bueno, Fran les va a hablar más a fondo de la detección de anomalías.
Claro, pues más que nada tenemos diferentes funciones dentro de OCI Vision, como decía Eric. Entre ellas está text detection, está lo que sería detector de objetos, que se puede utilizar para la parte que es detección de anomalías. Algo que buscamos mucho con OCI Vision es la democratización de la inteligencia artificial. Queremos hacerla accesible para que todas las personas y con diferentes casos de uso puedan utilizarla a su máximo, digamos, efectividad. Con la detección de objetos se puede analizar objetos dentro de imágenes, como se puede ver ahí en la foto, y se analiza y se puede detectar anomalías o casos no deseados dentro de, digamos, un proceso de producción industrial o incluso un proceso biotecnológico, como vamos a hablar un poco más al rato, en la detección de cáncer. Básicamente, esto nos ayuda a reducir errores humanos al automatizar esta detección de errores. Puede ser en video, como decía mi compañero Eric, puede ser en imágenes, que tiene aplicaciones más médicas. Y básicamente la arquitectura de Oracle Cloud nos permite hacer esto desde cualquier parte mientras exista un bandwidth suficientemente ancho para manejar la transferencia de información.
Muchas gracias, Fran. En este caso, trajimos una demostración. Esto es OC Vision. Lo corrimos en un sistema de detección de texto. En este caso, se puede ocupar, por ejemplo, no sé, podemos integrarlo a tickets de compra. Imaginemos que llega un cliente y le decimos, oye, ¿sabes qué? Necesitamos que nos envíes tu ticket escaneado, etcétera, etcétera. Podemos pasarlo esas imágenes a OC Vision y automáticamente nos puede regresar los valores clave. El nombre, no sé, clasificación de documento. ¿Qué es? ¿Es un ticket? ¿Es un recibo? ¿Es una nota? Etcétera, etcétera. Detección del lenguaje, es decir, podemos decir, este está en inglés, español, traducirlo.
e inclusive podemos hacer que detecte valores clave. ¿Qué nos referimos con esto? El nombre del cliente, no sé, el ID de la compra, si es para hacer un reembolso que sea ya de manera más automática. Entonces, básicamente OC Vision lo podemos hacer tanto o un sistema para objetos o si lo queremos integrar en aplicaciones mucho más complejas, como por ejemplo para extraer partes importantes de un texto. En este caso, bueno, también aquí ya está lo que les estoy diciendo. En este caso es un sistema, le están pasando un ticket y ahí le están pasando como una receta y automáticamente pueden ver que ya está extrayendo las partes importantes del texto. Entonces ahí están los key values y bueno. Ahora, bueno, nosotros sí tenemos servicios de inteligencia artificial, tenemos muchos, pero uno de nuestros principales, por así decirlo, focos es darle la infraestructura a las organizaciones para que corran sus modelos de inteligencia artificial. ¿A qué nos referimos con esto? Bueno, tenemos un partnership con NVIDIA, entonces tenemos ciertos recursos de NVIDIA que ellos nos ayudan. Ya como sus GPUs, algunos de nuestros sistemas donde pueden cargar sus modelos de inteligencia artificial tienen GPUs de NVIDIA. Y otra parte importante, bueno, son en Oracle Cloud Infrastructure está integrado todas las herramientas que les estamos diciendo. Desde Apex, si ustedes ya quisieran integrar una aplicación completa diseñada, podemos darles esas tecnologías. Oracle Analytics, Autonomous Database, que eso va a hablar más a fondo Fran. Y por supuesto, tenemos los recursos de NVIDIA.
Bueno, la parte de Autonomous Database, pues básicamente es como suena el nombre. Es una base de datos que se gestiona, si no completamente sola, la mayoría de los procesos que se tienen que realizar para mantener una base de datos, los hace solitos. Digamos, el parcheo, actualizaciones, cosas de seguridad, de identificación. Esta parte quizá no sea tan elegante como algunos otros modelos de inteligencia artificial, como OC Vision, que nos permiten reconocer, pero es esencial y hemos visto que la mayoría de nuestros clientes que utilizan servicios de inteligencia artificial montados en infraestructura Oracle utilizan la parte de Autonomous Database. ¿Qué aplicaciones tiene en inteligencia artificial? Tenemos la parte del entrenamiento de modelos. Como existe la conexión directa con Oracle Machine Learning, permite que solito dentro de la base de datos se analice los datos que existen dentro de esta y pueda generar un modelo predictivo con base a los datos que ya se tiene sin mucha interferencia del usuario. También tenemos la parte de soporte de Python, R, SQL. Sabemos que los ámbitos de inteligencia artificial son muy grandes y la diversidad de personas que utilizan inteligencia artificial hoy en día es aún más grande, sin mencionar pues la diversidad de lenguajes que existen. Entonces buscamos tener una plataforma amplia para de nuevo democratizar este proceso y que pueda ser accesible para todas las personas en diferentes casos de uso. Dentro de Oracle Machine Learning tenemos la capacidad de entrenar estos modelos con cualquiera de los lenguajes de Python, R, SQL. Incluso hay una herramienta de low code que nos permite generar modelos de inteligencia artificial. Asimismo, el análisis predictivo de los datos, como había mencionado, empodera a las compañías y a las personas que utilicen esos servicios a generar modelos más acercados e incluso modelos base para poder trabajar sobre ellos y generar modelos más certeros. Que básicamente queremos integrar no solo lo que es Autonomous Database, sino también pues toda la parte de inteligencia artificial que tenemos. Todo lo que mostró Eric, todo lo que les hemos estado hablando, lo integramos para tener un sistema holístico que permita realmente atacar esos casos de uso y generar soluciones completas que permitan atacar soluciones innovadoras.
Sí, como dice Fran, en este caso les queremos enseñar. Tenemos servicios de Oracle en todas las partes de la IA, desde darle servicios ya hechos, customizables, OC Vision, LLM, que ustedes nomás necesitan pues customizar, o inclusive es ya darles las herramientas para que ustedes creen sus modelos de inteligencia artificial, como dice Fran, de, no sé, los datos, limpiarlos, procesarlos, etcétera, etcétera, o inclusive ya hablando, darles la infraestructura necesaria para poder manejar su inteligencia artificial. Es por eso este diagrama. De hecho, por ejemplo, en OSI ya tenemos todos estos servicios que les estamos contando de inteligencia artificial, más el de Apex. Entonces, es una manera mucho más rápida que ustedes puedan crear aplicaciones ya complejas con muchos servicios de inteligencia artificial ya completos. Pueden crear una aplicación de Apex que pueda, no sé, fusionar OSI Vision, un chatbot inteligente, no sé, inclusive ya un sistema de texto y completarlo en un tiempo rápido. No tienen que gastar tanto. Entonces, esto es una parte importante de nuestros servicios de Oracle.
Y bueno, pasamos un poco a la parte de historias de éxito. Queremos contarle cómo algunos clientes han utilizado estas herramientas que les platicamos para solucionar problemas que antes sin inteligencia artificial, sin OCI Vision, no se hubieran podido resolver. El primero de estos tenemos la parte de manejo de bosques con Nibio. Nibio es una empresa de Noruega que a través de utilizar Oracle y con una herramienta llamada Smart Forest permite la detección y categorización de árboles en crecimiento e impacto de operaciones de tala. Como se puede ver en la imagen, utilizan drones y sensores para escanear todo el bosque y ver, digamos, en esa imagen son árboles en crecimiento. Ahí los va detectando, a través del modelo de Smart Forest, puede detectar en qué etapa de crecimiento están, si está saludable el árbol, si se encuentra de manera positiva la zona de manera ecológica y también el impacto de operaciones de tala. Para mantener el ecosistema saludable, lo que buscamos es tener pues un balance entre operaciones de tala y operaciones de sembrado. Estas herramientas nos van a permitir analizar el impacto de la tala específica en ciertas regiones donde se esté talando y ver cómo podemos hacer un offset de esto con operaciones de sembrado. La infraestructura que utilizan es la infraestructura OCI y permite un análisis profundo y la recreación, como se puede ver en la imagen, digital de algunas secciones del bosque. Esto es para un análisis más completo y profundo, donde vamos a poder tener un modelo en 3D montado en Oracle Infrastructure que nos va a permitir analizar más a profundidad cada árbol, los árboles que ya están, si están creciendo bien, si hay falta de nutrientes para el árbol, si existe algún impacto ecológico negativo del que tenemos que estar, digamos, conscientes para las operaciones de tala y cumplir estas metas de sostenibilidad que buscamos en los bosques de Noruega. En el siguiente caso de éxito que traemos, es el Machine Learning en Customer Service para videos. Esta compañía, Brain for Data, utiliza lo que les mencionaba, Autonomous Database. En este caso, lo que utiliza específicamente es Database 23 AI, que tiene la capacidad de generar estos modelos predictivos en base a los comentarios y al historial de lo que ya se ha utilizado, de lo que ya han preguntado a los clientes, de lo que se necesita resolver la mayoría de los casos, y genera este modelo predictivo que después, con la tecnología RAG de OCI, que permite generar agentes, estilo, digamos, ChatGPT, un chatbot, para Customer Service, y utilizan Apex para darle, digamos, un estilo de frente que los usuarios puedan interactuar con esto. Apex, como mencionaba Eric, pues es el sistema que utilizamos de frontend que nos ayuda a generar aplicaciones de manera rápida, low code, y puede permitir darle un frente a los modelos que quizás sea difícil interactuar con ellos de cualquier otra forma. Entonces, después de aplicarlo y después de, si no me equivoco, 2 meses, se tuvo un modelo que resolvió el 80% de los tickets de usuario. Esto libera, digamos, capacidad de la empresa para enfocarse en lo que ellos hacen mejor, que son los modelos de Machine Learning para analizar los videos. Entonces, nosotros buscamos también ayudar a las compañías en enfocarse en lo que son mejores y potenciar todas las demás partes como Customer Service para, de nuevo, permitir que ellos se enfoquen en innovar.
Bien, en este caso vamos a hablar de otras aplicaciones. Bueno, como dice Bran, Tenemos colaboraciones con muchas organizaciones alrededor del mundo en muchos ámbitos, pero en este caso vamos a hablar de aplicaciones médicas de tanto nuestros servicios de inteligencia artificial o de infraestructura. Bueno.
Sí, uno de los partnerships que estamos muy emocionados de tener es con el Instituto de Investigación Médica en Australia. Tenemos este video que más o menos les contará un poco de lo que hacemos. Los niños ahorita están contando un poco de sus historias, de cómo les ha impactado el uso de la inteligencia artificial a través del modelo predictivo utilizando OCI Vision. Detectamos anomalías en células que permiten detectar enfermedades.
Unos momentos con el video para que más o menos lo entiendan y ahorita hablamos un poquito más a profundidad. Ok, bueno, ahí tenemos una falla técnica, pero básicamente era lo que contaba Fran, es que creo que se va a poner.
No se le puede poner.
No, pero.
Okay.
Bueno,
les cuento un poquito más o menos de lo que venía en el video. Básicamente utilizan el modelo de OCI Vision, como estaba mencionando, para detectar anomalías en células, específicamente buscan células de cáncer en pediatría. Esto permite, digamos, tener si no con certeza del 100%, un avance de qué células pueden causar o qué células pueden ser indicadores de cáncer en los niños. Este instituto en Australia utiliza estas tecnologías como preindicadores. ¿Qué significa esto? No lo utiliza ya para decirle, para saber con 100% de certeza que existe una enfermedad, sino que ayuda a los doctores a decidir qué casos analizar más a fondo, si se necesita un tipo de scan especial para detectar cierta enfermedad o cierto cáncer en especial. Y también ayuda a los niños especialmente se utiliza en los niños, porque en los niños es más difícil detectar ciertos tipos de cáncer. Entonces, al utilizar esta herramienta, nos permite indicar si estos tipos de cáncer van a ser más comunes y empezar el tratamiento antes, que llega a salvar la vida de varias personas por evitar el crecimiento de este cáncer o enfermedad que pueda ser detectada a través de esta herramienta.
Fran, tenemos estas ayudas a instituciones de investigación médico. Otra cosa que queremos hablarles es de la detección de cáncer. Esto fue un proyecto que se hizo. Básicamente se cargó un modelo de OCI Vision para tratar de ayudar a le pasaban una imagen y podía decir qué tanta probabilidad había de que sea un cierto tipo de cáncer. En este caso, el modelo fue entrenado para cáncer de mama y cáncer pulmonar. Bueno, ahí están viendo es cáncer de mama. Me parece que la siguiente imagen que va a cargar es cáncer pulmonar. Entonces, justamente podemos devolver estos modelos de inteligencia artificial. De hecho, esta aplicación está hecha con OCI Vision en Oracle Cloud y con Apex. Entonces, podemos crear este tipo de aplicaciones sumamente con múltiples servicios de inteligencia artificial de manera rápida e integrar varias soluciones en un mismo lado de manera eficiente. En este caso, imagínense, podemos hacer esto. También otra cosa, también ayudamos a Emory University en un proyecto de Machine Learning para la predicción de enfermedades de Parkinson. Yo no sé si sepan, pero solamente en Estados Unidos se han diagnosticado, me parece, 90,000 personas con Parkinson en un año. Para 2030 creo que me parece que va a subir a 2 millones. Entonces ya es necesario crear estos modelos para tratar de predecir y tratar estas enfermedades a un buen tiempo. Los ayudamos a crear un modelo de Machine Learning con el cual podemos cargar diferentes aspectos de salud, radiografías, análisis médicos, etcétera, etcétera, para generar una predicción de qué tan probable es que esta persona tuviera Parkinson en un futuro y poder generar con un tratamiento preventivo. Vale, ya le hemos hablado de todas estas tecnologías que tenemos, tanto de todas las organizaciones con las cuales estamos trabajando, e inclusive de todos los servicios de inteligencia artificial que tenemos. Créanme, son muchos. Trajimos varios, pero colaboramos con muchas compañías que han usado estos servicios, ya sea para su cadena de manufactura, investigación, desarrollo, etcétera, etcétera. Colaboramos, trajimos las que creímos un poco más interesantes. Hay más allá afuera, pero queremos hablar de qué esperamos nosotros en un futuro con el desarrollo de estas tecnologías, porque claro, son tecnologías que tenemos, pero siguen teniendo un cierto nivel de fallo, un cierto porcentaje de fallo, que si lo tradujimos, bueno, puede ser desde una pérdida de un ingreso o inclusive una vida, ¿no? O sea, podemos hablarlo. Pero creemos que en un futuro estos servicios ya van a estar tan refinados que ya ese nivel de porcentaje va a bajar mucho. Por esa razón queremos hablarles de qué esperamos de que estas tecnologías evolucionen, de que la industria evolucione, ¿no?
Y bueno, más o menos queríamos contarles un poco, como decía Eric, de lo que esperamos saber en el futuro. En especial, pues nosotros acabamos de iniciar un partnership con OpenAI, extendemos su plataforma de Azure a Oracle y manejamos parte de la infraestructura de ChatGPT en Oracle Cloud Infrastructure. Y como mencionaba también en la parte del research, creemos que realmente estos partnerships con NVIDIA, como mencionó hace rato, y con OpenAI nos potencian y nos posicionan como un cloud provider que realmente está al frente de la parte de inteligencia artificial y estamos buscando llevar esta parte al siguiente nivel. De hecho, si regresamos un poquito a la parte de detección, a la demo que habías mencionado. Un poquito antes. Aquí, lo que hace básicamente es detectar diferentes pues partes dentro de, digamos, la glándula mamaria o el pulmón para ver si existen ciertos indicios que pueden llevar a cáncer. No necesariamente se utiliza ya como detección primaria, sino de nuevo como preindicador que nos ayuda a ver pues si puede desarrollar esta enfermedad. Esto queremos llevarlo al próximo nivel. Queremos que se pueda hacer esta detección con cierto grado de confianza tal que podamos llegar a decir se puede ser que se desarrolle un cáncer de este tipo en este time frame. Y democratizar esto para que hospitales que no tengan un centro de investigación tan complejo como algunos de los más importantes del país puedan utilizar también estas herramientas y que se puedan salvar incluso más vidas, que se pueda llegar esta tecnología a más lugares.
Como dice Fran, creemos que esta tecnología tiene mucho potencial. No lo hemos mencionado, pero trabajamos con organizaciones también como Twist Biosyn, que les ayudamos a crear un modelo de Machine Learning para el diseño de nuevo tipo de medicamentos. E inclusive ya trabajamos con otras organizaciones y universidades. Hay un proyecto de desarrollo de investigación de modelo para la predicción de enfermedades renales. Entonces, como dice Fran, tenemos la idea de que en un futuro lo más seguro es que ustedes puedan ir a un hospital o inclusive ir solamente a algún hospital o algún centro de que les tomen unos análisis, cargarlo de primera instancia a un modelo de inteligencia artificial y que el modelo les diga, lo más probable es que tengas esto y ya después checarlo con un médico. Como dice Frank, queremos democratizar la inteligencia artificial. Oracle es una idea de que queremos darle las herramientas tanto de infraestructura, servicios de inteligencia artificial y desarrollo de aplicaciones a las organizaciones que están desarrollando este tipo de cosas, ¿no? Digo, OC Vision tiene muchas más aplicaciones. El sistema de anomalías, como lo pueden ver, pues se utiliza para cáncer, pero lo podemos implementar en manufactura, sistemas de, no sé, podemos cargar un sistema de OC Vision que en un sistema de manufactura de autopartes y poder darle esta ayuda a estas compañías de manufactura a poder hacer de manera más redituable sus ingresos, de que tengan un porcentaje menor de fallos, etcétera, etcétera. Entonces, sí, creemos que este tipo de tecnologías va a ser vital en algún futuro. Claro, falta mejorarlas, tienen un porcentaje de fallo, claro, y pues es un fallo que buscamos que en algún futuro sea del mismo nivel que todos los demás, ¿no? Porque, bueno, tanto el diagnóstico médico, etcétera, tiene un porcentaje de fallo. Esperamos que en algún futuro estas tecnologías, estas aplicaciones tengan el mismo porcentaje de fallo y darle esta seguridad a la gente de que no porque sea un modelo de inteligencia artificial no tenga la misma confiabilidad que una persona.
Sí, y asimismo no solo estamos enfocados en la detección de anomalías, sino también en la predicción, por ejemplo, de resistencia a antibióticos por parte de ciertas bacterias y viruses. Esta es una parte, pues, que si han escuchado del mundo médico, es muy importante hoy en día, que se busca contrarrestar el efecto que tiene una mala prescripción o incluso una mala seguimiento de las instrucciones por parte de las personas que toman medicinas, que se genera esta resistencia a antibióticos y se busca contrarrestar a través de un partnership ahorita que con BioFi, una compañía latinoamericana de biotecnología, que a través de modelos predictivos generados utilizando Oracle Autonomous Database, generan predicciones acerca de qué personas han tenido ya o tienen potencial para desarrollar inmunización a ciertos antibióticos. Y esto ayuda a reducir el tiempo de tratamiento de 4 meses a incluso 4 semanas. De 4 meses a 1 mes llegamos a reducir el tiempo de tratamiento. Este es un partnership muy nuevo que se está desarrollando en prácticas clínicas, pero que nos interesa mucho a futuro por estos problemas en el sector médico y que impactan pues a todo el mundo.
Bueno, estos son los servicios con los que contamos, los partnerships, es por mencionar algunos. Si tienen más curiosidad, está en nuestra página web, ahí anunciamos nuestros partnerships, los proyectos en los cuales estamos colaborando, las tecnologías nuevas, y pues bueno, esperamos que todas estas tecnologías de verdad ayuden a salvar la vida de millones, ayuden a democratizar, sabemos que a veces en algunos lados es difícil el acceso a un médico, ya sea por X o Y razón, costo, tiempo, pero buscamos que estas tecnologías ayuden a la gente, que de verdad no solamente se queden en un proyecto, en una demo. Creemos que estas tecnologías van a ser vitales y van a estar funcionando en algún futuro. Muchas gracias.
Pues nos encantaría tomar preguntas.
¿Alguna cuestión? Lo que
¿Está abierto preguntas en el micrófono? ¿Sabes tú? No sé si hay alguna pregunta para acá.
Buenas tardes. Nada más tengo una duda con el modelo predictivo. ¿Cómo se entrenan? Porque, o sea, lo dicen así, uno se puede imaginar, ¿no? Están con el médico y el médico carga historiales de diferentes personas. Pero, pues, es que cada evolución es diferente, ¿no? O sea, tienen que llegar a un punto en común los historiales o los van segmentando de, no, pasó con esto, todo déjalo, no sé, o sea.
Depende de lo que se quiera realizar. Generalmente para este tipo de procesos, como lo es la detección temprana de cáncer o preindicadores para enfermedades pediátricas, lo que se busca es tener información acerca de cómo se ven, digamos, los órganos o las células, dependiendo del caso, cuando pueden tener este potencial de desarrollar ciertas enfermedades. Más que, digamos, agarrar todo el historial y ponerlo, buscamos tener, digamos, la clasificación adecuada para saber de ciertos tipos de enfermedades cómo puede llegar a evolucionar, y es por eso que mencionábamos hace rato el nivel de certeza. Ahorita pues existe un cierto nivel de certeza, pero por lo mismo que mencionabas que cada enfermedad evoluciona de diferente forma, pues no se puede, digamos, tener una certeza del 100% que es, digamos, que este preindicador se va a ver de esta manera en esta célula, en este órgano, pero buscamos aumentar esto para que los doctores y los expertos puedan tener una idea de cómo atacar o cómo detectar ya de manera temprana las enfermedades o las anomalías.
Tenemos otra pregunta por acá.
como dijo Fran, complementando tu respuesta, sí es buscar un sistema de patrones, más que nada. Y claro, como dice Fran, los modelos tienen un nivel de certeza, pero buscamos que en algún futuro, como, bueno, las pruebas de embarazo, etcétera, etcétera, tienen un nivel de fallo muy bajo, pero buscamos que esta tecnología tenga el mismo nivel de fallo que todas estas cosas que ya tenemos de manera común en la medicina. Vale.
Es que iba a decir, también se tendría que estar actualizando constantemente, ¿no? Porque puede que surjan nuevas enfermedades, como están diciendo que evolucionan diferente, o sea, qué tanto van actualizando ¿cómo se dice? Sus bases para poder predecir? Porque puede que mute de la nada y tenga que actualizar todo, no sé cómo.
Bueno, ahorita complemento a Fran, pero sí, lo que tú dices es un tema interesante. Sí, o sea, alimentar los modelos de inteligencia artificial con datos, créeme que sabemos que es algo muy vital. Digo, hay empresas ya enfocadas solamente a la recolección de datos. Hay algunas, si quieren, búsquenlas. Es un tema muy interesante lo que tú estás diciendo. Creo que es cosas que estamos buscando desarrollar, ver que estos modelos puedan evolucionar también a los rangos de las enfermedades, porque claro, todos tenemos cuerpos diferentes, pueden desarrollarse de diferente forma, pero estamos buscando que sí, tal vez que las bases de datos se llevan a actualizar o que lleguemos a un punto en común con estas enfermedades, ¿no? No sé si quieres comentar.
Sí, como mencionaba hace rato, en la parte de Autonomous Database nos ayuda bastante a esto de la actualización y de los modelos y de los datos. El manejo autónomo de la base de datos permite que los investigadores y los expertos se enfoquen en complementar los datos y asegurar que tenemos los datos categorizados de la manera adecuada para poder entrenar al modelo y que éste siga evolucionando conforme se actualiza esta base de datos, utilizando herramientas como Database 23AI y Oracle Machine Learning.
Bueno, teníamos otra pregunta por aquí.
Bueno, ¿cuál es el porcentaje de errores que hay en los modelos de IA y cómo podemos reducir de manera redituable estos porcentajes de error? Perdón. ¿Cuáles son los porcentajes de errores en los modelos de IA y cuál es la manera más redituable de reducir estos porcentajes?
Que si lo que manejas es un tema interesante, los porcentajes de errores. Depende de cómo estemos cargando el modelo de inteligencia artificial, depende con qué datos lo cargas, porque, o sea, si tú cargas un modelo de OC Vision con 10 imágenes, pues claro, lo más seguro es que tu error de fallo sea súper alto, más del 50, 70%. Por ahora, como te digo, es algo que depende de qué tanto entrenes tu modelo de OC Vision, de qué tan bien estén tus imágenes, tus datos. Sí, no sé si quieres agregar.
Claro, pues la parte de la búsqueda de la reducción de error es algo que intentamos mejorando los algoritmos detrás de OCI Vision, que son algoritmos, pues la verdad son innovadores de primera clase, pero como cualquier herramienta de inteligencia artificial está sujeto a los datos, como decía Eric, con los que está entrenado. Entonces, el porcentaje de error puede ser demasiado grande para poder decir con confianza tienes esta enfermedad, pero nos ayuda y ayuda a los expertos a definir, puede llegar a desarrollar esta enfermedad o existe una posibilidad de que tenga esta enfermedad. Entonces, este preindicador ayuda a mandar, digamos, más análisis más cercano a esta parte y que exista este error, pues quizás no se puede reducir a cero, pero buscamos reducirlo de la manera más grande posible para que podamos decir con confianza, como decía Eric, existe este fenómeno.
Teníamos otra pregunta ya. Sí.
Gracias. Buenas tardes. Sobre el programa Primavera en Oracle, ¿le han invertido en temas de inteligencia artificial? Sé que tienen una nube, pero nada más, ¿no? Entonces no sé si tienen ahí algunos avances. También preguntarles si por parte de la empresa tienen proyectos con el sector educativo y también con el sector de la construcción.
Sobre el sector educativo, sí. Estamos, Oracle, uno de nuestros fundamentos es la educación. Tenemos por parte Oracle Academy, que son accesos a cursos de todas nuestras tecnologías, que les damos el apoyo a universidades. La UNAM lo tiene, muchas otras universidades lo tienen. Son accesos que le damos tanto a los estudiantes, por si alguno se quiere certificar en alguna de nuestras tecnologías o quiere conocerlas, les damos esa capacidad. También, por ejemplo, en Oracle Academy les damos un cierto número de créditos para que utilicen nuestra nube. Me parece que son $300 o 5,000 pesos para que puedan estar jugando en nuestra nube y estar utilizando nuestra tecnología. Entonces, sí, tenemos una fuerte alianza. Me dijiste el sector de la construcción. Bueno, mira, a veces no podemos hablar mucho de ciertos clientes por razones de, tú sabes, confianza. Sí tenemos, no puedo especificarte mucho por razones de que hay clientes que no quieren hablar de... Entonces, sí trabajamos ahí, sí, pero bueno.
Pues más que eso, como Oracle tenemos la parte de infraestructura. Entonces, muchos clientes buscan la parte de infraestructura, pero también buscan la parte de software y software as a service. En Oracle tenemos muchos software as a service que utilizan empresas para diferentes capacidades, digamos, HCMs, ERPs, cosas de este estilo que todas las empresas necesitan utilizar para manejo de recursos humanos, para manejo de inventarios, point of sale, etcétera, etcétera. Con constructoras, como dice Eric, ahorita no me salta ninguna a la mente, pero estoy seguro que tenemos ahí algún, o sea, con alguno hemos trabajado.
Sí, puedo comentar.
Adelante.
Me refiero también al programa Primavera, que es de ustedes y que utilizamos bastante en el sector de la construcción para la programación, estimación, avance de obra. A esa me refería, además de tenerlo en nube, ¿le han invertido con inteligencia artificial para mejorar estos procesos?
Ok, mira, no estoy muy seguro. Lo más seguro es que sí, siempre buscamos innovar. Ya en la mayoría de nuestras aplicaciones o servicios cuentan con ayudas de inteligencia artificial. Lo más seguro es que si ahorita no hay una ayuda, salga en algún futuro. Sobre programas de construcción, como dice Fran, damos esta ayuda en cloud, pero también lo damos, no sé, ponte que tienes un proyecto de mapeo, de que estás mapeando una zona, etcétera, etcétera, y necesitas precargar esos datos. Tenemos ciertos servicios, hay un servicio que se llama Robin Edge. Robin Edge es como una computadora que te puedes llevar y es portátil y en esa puedes precargar servicios, modelos de Machine Learning, lo que ocupes y estarlas cargando ahí. No sé, renders o que estás cargando, mapeando toda una área para una próxima construcción, podemos darte ese servicio.
Otra pregunta, también si tenemos preguntas en el chat. ¿Alguien de aquí pregunta? Aquí. Cargamos.
Buenas, en cuestión de la resistencia a antibióticos, ¿cómo es la idea de la aplicación de la IA en ese caso?
Claro, en esta parte estamos colaborando con una empresa llamada BioFi, que si no me equivoco es brasileña. Ellos tienen un modelo predictivo que complementan con Oracle Generative AI, que utilizan para analizar el historial de diferentes pacientes que han desarrollado inmunización a este tipo de antibióticos, y utilizan esta información para catalogar expedientes de nuevos pacientes y ver si ellos tienen los indicios que nos muestran el historial para ver si han desarrollado o están en peligro de desarrollar inmunización a antibióticos. No sé si me explico.
Otra pregunta, o también checamos en el chat. Bueno, aquí no hay más. En el chat me parece que hay algunas o... Creo que no, más abajo, ¿no? Bueno, también si hay aquí más preguntas, todavía tenemos bastante tiempo. ¿Hay nadie? No sé si está aquí. Hay una pregunta de si los servicios de salud pública tienen o tendrán acceso a estos recursos. Los servicios de salud pública tienen o tendrán o se planea tener acceso a esto.
Pues lo trabajamos caso por caso. Hemos trabajado con servicios de salud pública en ocasiones anteriores, aunque si no me equivoco no se trabajaba todavía con inteligencia artificial. Estos servicios pues se pueden contratar de acuerdo a la necesidad del cliente, del caso de uso. Es posible que llegue a haber un partnership con servicios de salud, pero por el momento, si no me equivoco, no se tiene al menos en México.
Como dice Fran, hemos trabajado con hospitales o etcétera, etcétera, para estas demos, pero no, por ahora estos servicios, bueno, los demos que les hemos mostrado, detección de cáncer, etcétera, siguen siendo demos, por lo mismo de que tienen un porcentaje de fallo que es todavía un tema ahí, hay que refinarlo, pero sí, por ahora no hay acceso.
¿Más preguntas por acá? Hay otras en el chat. Hay una, me parece interesante porque me parece que es sobre democratización, que dice que justamente, bueno, habla sobre hospitales, pero en general sobre qué centros, yo pienso también educativos o de otra índole, pueden tener o podrán tener acceso a este tipo de tecnologías.
¿Se refiere a las tecnologías de Oracle Cloud, los servicios o los demos que...
Yo me imagino que sí, o sea, ambas, de hecho.
Para tener acceso a estos servicios, pues tenemos la parte que mencionaba Erika hace rato de Oracle Academy, que permite a los usuarios tener acceso a ciertas tecnologías de Oracle. Si no me equivoco, las tecnologías de inteligencia artificial, la mayoría sí están incluidas, hay algunas que no. Generative AI es algo muy nuevo que estamos viendo en Oracle. Existe solo en algunas regiones en Estados Unidos y en Europa. Todavía no se ha desarrollado o ampliado la red acá en México para esa específica tecnología, pero las demás se pueden utilizar a través de Oracle Academy y en un caso de uso ya más complejo se puede desarrollar en conjunto una tecnología con Oracle.
Ok, muchas gracias. Hay otras preguntas aquí en el chat. Hay una que se me hace muy interesante que voy a leer, que me pregunta si una célula llega a una mutación, ¿la IA puede identificar la enfermedad con los modelos actualmente desarrollados? Como digamos, me parece que es como fase temprana.
Ok, bueno, en el caso de dependerá de cómo esté entrenado el modelo. Esto depende enteramente de cómo esté entrenado el modelo, el índice de fallo. Por ejemplo, si fuera cáncer, pues se puede desarrollar de ciertas formas y puede, no sé, que el modelo no le acerte. Entonces, la respuesta sería depende de cómo esté entrenado el modelo de inteligencia artificial o el servicio en el cual estemos haciendo, ¿no?
Sí, buscamos siempre tener, como decíamos hace rato, el error mínimo, pero depende de cómo se entrena el modelo, los datos que se están analizando y buscamos que se complemente con lo que han dicho expertos, que análisis de expertos y de médicos, que no solo sea el análisis de inteligencia artificial, porque al menos al punto al que estamos hoy en día todavía existe pues cierto margen de error.
Tenemos una pregunta por acá en vivo.
Gracias. Una pregunta. ¿Oracle comparte modelos de open source como en Hugging Face, por ejemplo? Perdón, sí. Que si Oracle comparte modelos open source, por ejemplo, en Hugging Face, para acceso a las personas.
No te sabría decir con exactitud si hemos desarrollado algún modelo open source. Por ahora conozco la tecnología OCI Generative AI. Esta es propietaria y se puede utilizar utilizando OCI Cloud, pero no está disponible open source.
Sí, como dice Fran, estas tecnologías no son de código abierto, me parece. Son propiedad de Oracle. El código madre sí, lamentablemente, bueno, es nuestro, entonces justo no, a menos que seas un desarrollador vas a tener acceso, pero sí, no.
Bueno, aquí en el chat hay otra pregunta ligada un poco a eso y nos preguntan si están disponibles los conjuntos de datos de imágenes para las IAs, todo esto, o son privadas.
La verdad, eso es una respuesta. Me parece que las imágenes de estas demos que mostramos son pertenecientes a las universidades o son de acceso, porque estos proyectos se hicieron en colaboración con hospitales, centros, etcétera. Entonces, yo creo que más bien son más de acceso de ellos, ¿no? Y bueno, como dicen, para que estos modelos lleguen a ser ya en un futuro reales, pues también hay un tema ahí de propiedad de datos, de que la gente le dé acceso a como por ejemplo, nuestra compañía para cargar sus modelos o sus imágenes, sus radiografías, sus análisis, para entrenar nuestros modelos. También eso es un tema, ¿no?
De hecho, no puedo confirmar con exactitud, pero puedo decir que muy probablemente no estén disponibles estos datos con los que se entrenaron los modelos, en especial los modelos de predicción de enfermedades o anomalías en casos de sector salud, por cuestiones de seguridad de información de paciente. No se puede divulgar estos datos, no se pueden tener en público, por así decir. Las universidades con las que se trabaja buscan especialmente la seguridad que puede ofrecer Oracle Cloud, que es bastante robusta y busca mantener lo que se necesita mantener confidencial.
Aquí hay otra pregunta.
Por ejemplo, en el caso de OC Vision, ¿es en sí un modelo base que se reentrena o es como una arquitectura para crear un modelo ya con sus datos propios?
Vale, es los dos. Realmente OCI Vision existe de dos formas, que son los modelos ya preentrenados con datos de Oracle, que sirven para algo, digamos, propósitos generales, pero si se requiere un modelo más complejo, más, digamos, específico, se puede generar modelos customizados a partir de datos del cliente o personales. Se suben a la nube y de ahí se puede utilizar para entrenar el modelo de OCI Vision específico que se requiera y cumplir con la necesidad.
No sé si hay más preguntas. Podemos pasar una del chat que nos pregunta, ¿tan complicado fue encontrar estas nuevas áreas de oportunidad para poder comenzar a desarrollar estos?
De nuevo, ¿cuál?
¿Qué tan complicado fue encontrar estas nuevas áreas de oportunidad para poder comenzar a desarrollarlas?
Mira, no creo que sea complicado encontrar estas áreas. Creo que muchas áreas de la vida diaria del sector salud, financiero, tienen muchas mejoras con inteligencia artificial. Creo que el reto más que nada es tratar de generar un modelo, una demo o un servicio ya con todos estos servicios de Oracle y que le dé la misma confianza a la gente, ¿no? Porque, bueno, imaginando que nosotros sacáramos un servicio de diagnóstico médico, por ejemplo, yo creo que mucha gente tendría aún ese sentimiento de decir, bueno, no estoy tan seguro de lo que me vaya a decir este modelo, confíe en él, ¿no? Creo que también ese es un tema, ¿no? No sé si quieres agregar algo, Fran. No.
Bueno, tenemos una pregunta por aquí en público.
¿Qué tal? Buenas tardes, Eduardo. También una pregunta sobre cómo inyectan sus datos. ¿Todos son reales? O sea, bueno, sé que mencionaron que tienen colaboración con distintos hospitales, pero mi pregunta es si también han generado datos sintéticos. O sea, como lo que se hablaron en otras partes del.
Así es. Bueno, si quieres. Sí, contestando tu pregunta.
¿Complementar?
Los datos.
Es lo mismo para más o menos la misma pregunta. Desde aproximadamente 2012-2013, IBM estuvo desarrollando un proyecto parecido a través de Watson. ¿Hay algún contacto, intercambio de información, etcétera, sobre eso? Sí, Watson, incluso IBM compró un hospital para, no para el hospital en sí, sino para tener todas las imágenes, sobre el tema de cáncer. Es pregunta, más o menos complementaria con la compañera.
Sobre específicamente un partnership para esta sección, no estaría muy seguro decir si tenemos partnership con IBM, con Watson, pero para la parte de datos sintéticos, creo que podría decir que varía caso por caso. Mostramos diferentes casos de uso, diferentes universidades. Buscamos que los expertos digamos, del cada campo puedan proporcionar los datos que ellos creen válidos en especial en el sector salud, porque es algo pues muy sensible, no puede haber falsos positivos, por así decirlo, o al menos buscamos reducir la capacidad. Entonces, varía caso por caso, dependiendo de lo que se quiera realizar y dependiendo del uso del modelo.
Hay aquí otras preguntas en el chat. Juan pregunta si para la detección de cáncer se puede utilizar para otros tipos de cáncer como cervicuterino, cerebral, entre otros, y si es solo, pues, o si es solo para detectar, y bueno, también se puede utilizar para detectar la severidad del cáncer, para ver de qué grado de cáncer es.
Sí, bueno, la demo que les mostramos ahorita solamente fue entrenado para dos tipos de cáncer. Fue entrenado para cáncer de mama y cáncer pulmonar. Pero sí, el modelo de OC Vision sin problemas se puede ocupar para entrenarlo para varios tipos de cáncer. Claro, habrá temas que hay que ver porque tal vez, no sé, eso ya será cuestión de los expertos en medicina, de ver si algún tipo de cáncer tiene ciertas similitudes con otro y tratar de encontrar de que el modelo no se confunda, ¿no? Entonces, sí, que podemos hacer que el modelo funcionen para más tipos de cáncer y dar un porcentaje de qué tan avanzado está, sí, sí se puede, ¿no? Pero ya será un tema de hacer más o meterle más datos y customizar más el modelo.
Pues tenemos tiempo para unas últimas preguntas. No sé si alguien aquí tenga otra pregunta. Si no, también podemos tomar.
¿Creen que este tipo de tecnología como que reduzca mucho los costos como de detección del cáncer o en general de ese tipo de cosas?
Eso es lo que buscamos realmente. Buscamos con una detección más temprana, reducen los costos no solo de detección, sino también de tratamiento. Creo que en general la detección temprana potencia a las decisiones que van a realizar los médicos y los expertos respecto a cada caso, porque obviamente pues cada caso no es solo un número, sino también una persona que puede padecer de esta enfermedad. Entonces cada caso es diferente, pero sí buscamos reducir los costos de tratamiento y de detección. Si tenemos un indicio de que cierta persona tiene una alta probabilidad de tener cierto tipo de cáncer, podemos mandar directamente a esa persona a hacer el scan que puede confirmar en lugar de una variedad de tratamientos para detectar al menos cierta cosa. No sé si me explico.
Bueno, no sé si aquí hay más preguntas. Si no, bueno, podemos tomar una última del chat que nos pregunta cuál es la proyección de avance y actualización para los modelos dentro de 5 años, más o menos.
Ok, nuestra idea de aquí a 5 años es obviamente buscar que tanto estos modelos de reconocimiento, etcétera, y ya implementados en modelos de medicina, infraestructura, lo que sea, tengan un índice muy bajo. Hablamos, bueno, yo lo mencionaba, tanto en el diagnóstico médico, las pruebas de embarazo, etcétera, llegan a tener un porcentaje de fallo, ¿no? Nuestra idea es que estos modelos, las demos y estas tecnologías lleguen a tener el mismo porcentaje de fallo que todas las demás tecnologías que se ocupan para este diagnóstico, ¿no?
Bueno, pues les agradecemos mucho a Eric y Francisco. Les tenemos un presente que se les va a otorgar ahorita. Adelante. Damos un aplauso. Muchísimas gracias. Entonces, pues continuamos con las presentaciones. Sigue el doctor Antonio Marín Hernández. Vamos a dar todo.
Gracias.
Aquí ustedes. Y me parece que ya está todo listo. ¿Vas a conectarte?
Tengo la memoria.
Sí, más fácil.
Está pesada. Oh, la pasamos. Tienes todos los labores completos.
Sí. Entonces, si gustan tomar asiento para ir comenzando. Tiempo. Bueno, vamos a ir comenzando en lo que nos organizamos bien. Entonces, vamos a presentar esta plática que lleva el título de Desarrollos y aplicaciones de la robótica inteligente en la Universidad Veracruzana, que es presentado por el doctor Antonio Marín Hernández. Él es licenciado en física por la UV desde 1995, obtuvo el grado de maestro en inteligencia artificial por la UV en el 98 y el grado de doctor en el Institut National Polytechnique de Toulouse, en Francia, en 2004. Es investigador permanente en el Instituto de Investigaciones e Inteligencia Artificial de la UV, cuenta con perfil deseable PRODEP y es miembro del Sistema Nacional de Investigadores Nivel 2. Sus áreas de interés son robótica móvil y de servicio, interfaces humano-robot, procesamiento digital de imágenes y percepción 3D. Ha sido investigador invitado en el Laboratorio de Análisis de Arquitectura de Systems en Toulouse, Francia, en la Freie Universität Berlin, en Berlín, Alemania, y en el Instituto de Sistemas y Robótica de la Universidad de Coimbra, en Coimbra, Portugal. Cuenta con más de 80 artículos científicos publicados en revistas y congresos internacionales. Ha dirigido una decena de proyectos científicos, entre ellos ciencia básica, innovación, etcétera, y registrado al menos 8 patentes relacionadas con algunos de estos proyectos. Ha ganado 2 veces el premio a la investigación interdisciplinaria del UV y en 2020 le otorgaron el Premio Estatal de Ciencia y Tecnología en Veracruz en el área 1, Físico-Matemáticas. Entonces le agradecemos al doctor Marín por estar aquí y damos pie a su plática.
Muchas gracias por la presentación. Ok, bueno. Ya se ve la... Gracias. En esta plática les voy a detallar algunos de los desarrollos y aplicaciones que hemos hecho de robótica, pero sobre todo con inteligencia artificial en la Universidad Veracruzana. Entonces, por un lado está la robótica de manufactura y nosotros lo que hacemos es una línea de investigación que llamamos robótica inteligente. Entonces, el contenido de esta charla va a ser el siguiente, una pequeña introducción. Ay, una disculpa por ese errorzote, que estuve cambiando las slides. Vamos a hablar un poco del contexto general, sobre todo en México, que nos va a dar posiblemente la pauta para el panel que está a continuación. Veremos algo de los robots de servicio, que es lo que estamos trabajando sobre todo en la Universidad Veracruzana, en los trabajos actuales que tienen que ver con diferentes temas, particularmente con robótica de servicio, y finalmente algunas de las líneas de investigación futura. Bueno, claro, las conclusiones. Entonces, bueno, los robots de servicio ya funcionan en diferentes lugares, ya podemos encontrarlos en museos, oficinas, aeropuertos, estaciones de trenes y hoteles. Y una de las preguntas que siempre nos hace el público en general es, ¿y los hogares? ¿Para cuándo vamos a tener estos robots efectivamente trabajando en nuestros hogares? Bueno, ya tenemos algunos de estos robots. Los robots aspiradoras son el primer producto exitoso de la robótica que se vende común al público en general. Pero cuando nosotros pensamos en robótica de servicio en los hogares, pues lo que estamos pensando es como un robot, en este caso de la otra imagen, que pueda ayudarnos, un poco como lo que presentó esta mañana Giorgio, que es un robot manipulador y muy similar a un humano que nos va a estar ayudando en todas las tareas de casa. Tiene 50 años, o un poco más, 55 años, que nos planteaban estos robots. Estos robots, estas 2 series particularmente, nos hablaban de robots de servicio. Los Jetson o los supersónicos y Perdidos en el espacio. Son series televisivas de finales de los 60s, inicios de los 70s. Ya ahí estábamos planteando que para estas fechas íbamos a tener todos este tipo de robots de servicio. Y todavía no los vemos. ¿Dónde están? ¿Qué nos falta por llegar a completar este tipo de robots? Pues la verdad es que ya no estamos tan lejos. Sin embargo, todavía falta alguna parte de desarrollo para que estos robots ya puedan estar en nuestras casas. Algunos de los ejemplos de estos robots, aquí no sé cómo ponerle play. que es un video, pero no funcionó a la primera. No encuentro el video. Ok, entonces, sí es lo que me temía con los cambios. Esperemos que los otros sí estén. Hace algunos 20 años surgió una empresa, Willow Garage, que proponía hacer este tipo de robots de servicio y que iban a estar por todos lados. La empresa quebró y actualmente el robot era muy caro, no existe ninguno de esos en México, extremadamente caros. Y pues bueno, se comenzó a realizar ya trabajos en este estilo. Nosotros en la Universidad Veracruzana tenemos un robot similar, muchísimo más modesto. Esta es la versión sin brazo, tenemos una versión con brazo, pero lo que hacemos nosotros en la Universidad Veracruzana lo podemos llevar a cualquiera de los otros robots que estamos presentes. Por ejemplo, tenemos mucha colaboración con el Laboratorio de Arquitectura y Análisis de Sistemas en Toulouse, y nuestros estudiantes van y prueban los algoritmos primero en Jalapa y después se van a allá o a alguna otra universidad a probar estos. Contexto general, rápidamente. ¿Por qué? Porque estamos en México. Hacer robótica muchas veces ha sido criticado. ¿Qué va a pasar? Vamos a suprimir muchos empleos. Sí, efectivamente. Y, sobre todo, donde se puede justificar es en los trabajos difíciles o peligrosos. Pero no solo eso, también los trabajos monótonos. Acaban de ver una plática de Amazon en donde estamos colocando robots para estar haciendo ciertos trabajos que realmente son monótonos y difíciles para estar haciendo para una persona. Pero también van a desaparecer todos los trabajos mal pagados. Todos los trabajos mal pagados deberían o tienen que desaparecer. Y ahorita les voy a platicar por qué. Pero sobre todo, en países como el nuestro y sobre todo en Latinoamérica, lo que va a suceder es que todos los trabajos sin valor agregado van a desaparecer. Van a ser hechos por máquinas o van a ser hechos por robots. Y entonces, ¿vale la pena hacer esto en México? Pues sí, tenemos un problema en México. Esta es nuestra pirámide poblacional. Como ven ahí, del lado derecho, izquierdo, estamos envejeciendo. Estamos envejeciendo. El promedio de vida en el 2000 eran 22 años, 2010 estamos en 26 años y 2020 en 29 años. Nos estamos haciendo viejos, es una población que se está haciendo vieja. Ustedes no lo recordarán, pero los adultos de mi edad lo recordaremos de que hubo una iniciativa gubernamental para reducir la población. Se llamaba La Familia Pequeña Vive Mejor. Resultó que fue un éxito y es un problema. Pasamos en 2 décadas de 7 hijos por pareja a 1.9. Obviamente es un promedio. Y en 2 décadas. Lo que no sucedió en países europeos o en Estados Unidos y Canadá o en países orientales como Japón. Entonces, el problema es grave porque entonces lo que tenemos ahí es, si ven las líneas azules y la línea, pues guinda, los servicios de salud, educación y pues todos los servicios municipales. Si no, no hay manera. Si esos ganan menos de lo que nosotros estamos ganando, no hay manera económica de salvar eso. Y eso me da la justificación por qué hacer robótica. ¿Sí? Todos esos trabajos serán eliminados, decía, los trabajos mal pagados, que los hagan los robots. Pero ¿qué haremos con toda esa demás gente? Que yo creo que será de nuevo rediscusión para el panel. Pues tendremos que darles opciones para que puedan ganar más. Una de las opciones es, pues, generemos estudiantes con capacidades altas para resolver problemas y que estos nos traigan empresas o generen empresas y ayuden a la economía de un país como el nuestro. La inversión en ciencia y tecnología es una solución, no es la única, para este tipo de problemas. Adicionalmente, ¿cómo es el futuro? Pues hay carreras que van a desaparecer. Contabilidad y administración desaparecen. pues gerencia, administración, pues lo tomarán también la inteligencia artificial. Sin embargo, tecnologías de la información está previsto que todavía incremente y algunas situaciones raras, recursos humanos, pero sobre todo el trato con la gente. ¿Por qué? Porque todavía no somos capaces de generar robots ni contestadoras que sean eficientes al tratar con la gente. Se va a requerir de gente que esté tratando con gente para poder solucionar esos problemas. Cuando ustedes van a una cadena comercial y hay una gente que no los atiende bien, pues obviamente es disgusto y es una pérdida para el comercio. Esa persona es reemplazable. ¿Sí? Entonces, si alguien quiere venderte o ofrecerte un servicio o darte los pros y contras de un producto, pues aquella persona que es apasionada será la idónea para este tipo de cosas y la empresa le pagará mejor. Entonces, eso va a suceder. Finalmente, pues bueno, estamos en la cuarta revolución industrial, se espera la quinta revolución industrial y como ven ahí, la quinta sería obviamente esto que está comenzando ahorita, que es la emergencia de la inteligencia artificial. La inteligencia artificial utilizada para miles de productos y servicios a lo largo de nuestro mundo. ¿Qué hacemos en la UB? Bueno, en la UB hacemos diferentes desarrollos. Por ejemplo, aquí trabajamos mucho con interacción humano-robot. Es un ambiente complejo. Estamos haciendo que nuestro robot siga, en este caso, una pequeña botellita de refresco. Y lo interesante aquí es que hace unos momentos lo platicaba Giorgio, tenemos que considerar el factor humano. Y ahí es bien importante y quisiera retomar esto para dar el panel nuevamente. Disculpen que diga todo eso, pero es para invitarlos que no se vayan. Como latinoamericanos funcionamos completamente diferente a los orientales, a las culturas orientales u occidentales en el caso de Europa. Tenemos una cultura completamente diferente. En este caso, por ejemplo, es importante que el robot parezca robot y no se acerque tanto a una persona como en el caso de los productos japoneses. Hay un rechazo muchas veces en la parte occidental para cuando el robot parece